Sumant has joined regularly.
Yes, sir.
Dr. Sumant is joined.
Yeah, Sumant Bhattacharya sir is joined. Yes, sir.
Huh?
Yes, sir. He is joined. And R.R. Deshmukh sir is also joining with us, sir.
Oh, Deshmukh sir joined. Kaha? His face
Yes,
is
sir.
not there.
Yeah, actually he is joining. Yeah, now he is joined. Good morning, Deshmukh sir.
Good morning, sir. Good morning.
Good morning,
Deshmukh
sir.
sir,
Very good
namaskar.
morning. Good morning. कैसे हैं?
Yeah, Chaudhary Sahab,
Namaskar.
Deshmukh sir.
yes, sir.
हाँ, you meet Dr. Senthil Kumar. Dr. Senthil Kumar.
Yes, sir. Yes.
Rohit?
Good morning, bro, sir. Good morning.
Good morning.
Good morning,
Good
bro,
morning.
sir.
Dr. Senthil Kumar,
Good morning, bro, sir.
you meet Dr. N S Chaudhary, the
Namaskar.
Honorable Vice
Okay,
Chancellor
brother.
of the Uttarakhand Technical University, the chief guest of the
Okay.
today's occasion. Sir, Dr. Senthil Kumar is the very dynamic secretary of Kanchipuram
Okay.
chapter, PSI Kanchipuram chapter.
सेंथिल कुमार जी नमस्कार, प्रणाम.
Namaskar, sir.
नमस्कार.
And
Good morning.
Deshmukh sir, you know very well to him, Professor
Yeah.
Deshmukh.
Yes, yes,
And
sir.
Yeah. Good morning,
Yes, sir. Yes, sir.
we are,
Senthil Kumar. Yeah. Good morning.
Good morning, sir. Good morning. Good
we
morning,
are
sir.
having
Good morning.
Dr. Sumanta from Royal University, Bhutan. Dr. Sumant. Dr. Sumant Bhattacharya, Sumant.
Yes, sir. He is connected, but now, yes, sir. Yes,
Good morning,
Rohit
sir.
Dr. Sumant, meet the Honorable Vice Chancellor.
नमस्कार.
Namaskar, sir.
Good morning.
Good morning.
Sumant is from the Royal University, Bhutan. So, he's the computer science head there. Hello.
Today the network is a huge issue out here.
Networking issue in Bhutan, obviously.
No, on Saturdays and Sundays there is a maintenance by the DrukeNet and Bhutan Telecom. So
You have joined?
every Saturday and Sunday.
जॉइन कीजिए. चौधरी साहब वेट कर रहे हैं. आप जॉइन करेंगे तो हम लोग स्टार्ट करेंगे. जल्दी जॉइन. रोहित.
Yes, sir.
ये YouTube and Facebook दोनों चल रहा ना?
Yes, sir. And Dharam Singh
Live?
sir is also. Yes, sir.
Huh?
Yeah, we are having the YouTube live, and same thing is
Facebook
on
live, both
displayed
are
on
in live.
Facebook live. Yeah. Dharam Singh sir is joining with us, sir.
हाँ, जॉइन कर लिए.
Yes, sir. Good morning, Dharam Singh Jat sir. Please unmute, sir.
Good morning, sir.
अरे good morning धर्म जी. And Chaudhary sir is there.
Good morning, Chaudhary sir.
Good morning, धर्म सिंह जी. बहुत after a
बहुत
long
दिन
time
बाद.
we are meeting virtually.
After a long time.
Yes.
Actually, Dr. Dharam Singh ji is very much helpful for the CSI and our webinars. I don't think he must have participated more than 1 dozen of the webinars. Isn't it true?
And Professor Nayak, one important thing, in 2010 during the CIS convention, we are neighbor, Professor Chaudhary as well as Professor Rohit Kumar, and we were there. We stay in the same room.
2010 CSI convention.
Yeah, in Bombay.
In Mumbai. At that time,
So,
that
from 2010, we have, from 2010, we have close relations.
MD Agrawal, Timothy Sahib had been the president, MD Agrawal was the vice president from Mumbai.
Yeah.
Yes. So, ठीक है, we should start then.
Yes, sir. Yes.
Yes, sir.
Okay.
So,
Rohit.
yes, sir, we can. Yeah. So once again, very good morning to all dear respected participants, guests, and our respected dignitaries in this today's one-day international webinar on the very important and hot topic, that is Industry 4.0. I, Professor Rohit, Assistant Professor IIBM Patna, I welcome you all in this today's webinar. So we will proceed with our first session, that is our opening address. And for that, I like to welcome Professor Dr. A.K. Naik sir, who is the Chief Advisor of IIBM Group. And I think we did not need the introduction for him, as we already know him. Nowadays he is becoming famous as a webinar man, as same as the missile man we will call the APJ Abdul Kalam. So with these words, I like to welcome Professor Dr. A.K. Naik sir for opening address.
Thank you very much, Rohit, for your great complimentation. That webinar man, of course, there is no doubt we have conducted more than 600 webinars during the pandemic period. Very good morning to everybody to this August International Webinar on a very vital theme, Industry 4.0, and welcome you everybody also. Honorable and respected learned Vice Chancellor of the Uttarakhand Technical University, my old colleague and academic guide, and to whom I know since last several years, Dr. N S Chaudhari ji, the keynote speaker of the today's international webinar, and our old colleague, and we are also very known to one another since more than 20 years, Dr. Dharam Singh Jadji, the learned and very reputed professor of computer science and engineering of Namibia University of Science and Technology. And recently he has also got the approval from the UNESCO also, the UNESCO professor. And the invited speaker of the today's international webinar on Industry 4.0, who will be citing of many of the case studies, the General Manager of Steel Authority of India Limited, Ranchi, Mr. Mukesh Kumarji, and many invited guests who have joined on this auspicious occasion. Let me name few of them. My most beloved younger brother and a professor and a head of the Department of Computer Science and Engineering, Marathwada, Baba Saheb Ambedkar Marathwada University, and the former member of the National Nomination Committee and former president of the ICT section of Indian Science Congress, Dr. R.R. Deshmukhji, our most vibrant and dynamic secretary of the Computer Society of India, Kanchipuram chapter, who has been credited of organizing more than 30 number of webinars and seminars in virtual mode during the pandemic period, Dr. Senthil Kumarji, and Dr. Sumat Bhattacharya ji from the Royal University, Bhutan, and the professors and teachers of the Indian Institute of Business Management, Dr. Zakir Hussain Institute, other professors and teachers from the different colleges and universities, and the vast participant of the student participants who have been generally connected with the YouTube and Facebook Live. And ladies and gentlemen, it is indeed a great pleasure for me to welcome each of you to the 38th number of webinars conducted by Indian Institute of Business Management in association with the various statutory bodies, in association of the Computer Society of India, Indian Society for Technical Education, Dr. Zakir Hussain Institute, IGNO, and so far. And in 38 number of webinars, we have conducted more than 30 numbers of webinars in the field of computer science and engineering. But after from 31, we have started conducting the webinars on the areas of the management. We have conducted digital marketing, we have conducted big data analytics, we have conducted prospects and challenges in rural marketing, conducted human resource development for next decade, conducted emerging demand of the financial planning for growth of the business and industry. And today we are having a topic which is equally suitable for the management as well as the computer and IT stream, that is Industry 4.0. The content of the industrial application might be the interest of the management group or management students, and its implementation and architecture that is based on the Internet of Things and Internet of Everything and robotic concept might be the interest of the computer stream and IT stream. And in this occasion, we are very much grateful that we have got such a high level personality and an academician of not only national, rather international stature, and a technical expert and teacher, Honorable Vice Chancellor of Uttarakhand Technical University. I can proudly tell, due to my association with him as a colleague since last several years, it is a pride for all of us. Sir, on behalf of the Indian Institute of Business Management and Dr. Zakir Hussain Institute of Group of Institution, and on behalf of the managing committee, on behalf of the faculty members and the student community, on behalf of this webinar also, I extend my sincere gratitude, millions of thankfulness, and billions of gratitude for your gracious presence here to inaugurate this auspicious webinar based on a very vital theme, Industry 4.0. There is no introduction is needed so far as the capability, dynamism, and past experience of Dr. N.S. Chaudhari is concerned. A personality who started his career from many of the universities, started the career from the university and have been associated with many of the universities of the country in different capacities, and associated with one of the most famous and important universities, Devi Ahilya University, Devi Ahilya Vishwavidyalaya at Indore, and having serving several years in the Singapore's in very prominent capacity, and had been the founder, professor, head, and dean of the Indian Institute of Technology Indore, which is one of the IITs of the excellence, and served there as the capacity of the dean, administrator, as well as the director in charge for some years. And today, he is heading the Uttarakhand Technical University, one university of the national repute, devoted and dedicated for promoting and spreading of the technical and technical education, engineering education of the country. Sir, once again, on behalf of this group of institutions, on behalf of my own behalf, as well as on behalf of the webinar, we extend our sincere gratitude and thankfulness for your gracious presence on this occasion and for your kind consent to be the chief guest and deliver your inaugural address on a very prominent and vital theme, Industry 4.0. In the same time, we are also expressing our hearty welcome and sense of gratitude for the gracious presence of Honorable Dr. Dharam Singh Jat, who had been one of my most oldest colleagues in the forum of working in the Computer Society of India, in the forum of working in the different academic fields in the computer science and information technology. Dr. Dharam Singh Jat as a very acclaimed academician, having the several years of experience in the Indian universities, in the capacity of professor, head, and dean. Now he is serving as one of the very prestigious professor at the Namibia University of Science and Technology, and we all are proud. Recently, the UNESCO has approved him to be a professor of under the banner of the UNESCO. Really, on behalf of the academic committee, on behalf of the management committee, on behalf of the students and teachers of our group of institutions, and on my own behalf, we extend our hearty welcome and sincere gratitude, as well as our billions of thanks for your gracious presence here and for your kind consent to deliver the keynote address on this auspicious occasion. And your contribution to the field of Computer Society of India, in particular, and to the field of computers for the enhancement and for acceleration of the culture and ethics of the computer science and engineering in the country of India cannot be ignored. And you have generously contributed in more than dozens of the webinars conducted by us in different locations. I will have to mention here to our honorable chief guest, sir, you became also kind enough to inaugurate one of our largest webinars that has been conducted under the banner of Computer Society of India headquarters, the national headquarters at Chennai, that emerging demand of online education. And today it is your second appearance again to inaugurate and deliver the inaugural address. By the meantime, I must have to proudly inform before the honorable chief guest and the honorable keynote speaker that under the Computer Society of India banner, we have conducted near about 600 number of webinars till today, and 78 number of honorable vice chancellor from different parts of the country have addressed in the webinars, either in the capacity of chief guest or in the capacity of president of the function or in the capacity of guest of honor or keynote speaker. And under the banner of Indian Institute of Business Management, we have also invited near about 28 number of vice chancellor till today to make these webinars glorified in the capacity of the chief guest or in the capacity of the presiding over or the keynote speaker or the guest of honor. In the same time, I must have to welcome my beloved younger brother and the regional vice president of Computer Society of India, in charge of the state of Odisha, Jharkhand and Chhattisgarh, Mr. Mukesh Kumar, who is the general manager of Steel Authority of India Limited and placed at Ranchi. And he will be the speaker of the today, eminent invited speaker, who will be deliberating upon how the Industry 4.0 is adopted and accepted and going to impact in the steel and mining area, with the citing the number of case studies, because practically they are in a process of implementing the complete Industry 4.0 in the Steel Authority of India Limited. I also welcome all other dignitaries who have been present here on this auspicious occasion, including Dr. Senthil Kumar, Dr. R.R. Deshmukh, and Dr. Sumant Kumar, and Dr. Tiwari from Nasik also. He is a regular participant, and all of you. And also extend my welcome to all the participants of the different institutions of the country and abroad, including all our nearest and dearest student participants who will be getting benefited by participating on this online and virtual international webinar. In the same time, keeping the Industry 4.0, I have just given the justification as the basic theme of this webinar, because everybody knows, and it is a topic which is equally inclined towards the field interest of the peoples of the management as well as the computer science. Everybody knows, after the recent development in the different emerging computing technologies, and now it is the time, I always tell, it is the time of the integration of the technologies. The integration of the technology should be there, and our young and researchers and our thinkers should always think how the different emerging computing technologies can be appropriately integrated so that the platform application platform area can be there for the benefits of the mankind, and how this technology, this ICT application can be available at each and every sectors of the application, including the remotest part of the country, to fulfill the demands and catering the needs of the common citizens of the people through the e-governance projects. That is, services at the demand should be also fulfilled. And so far as the industry 4.0, perhaps it has been developed, it has been there due to the emergence of the IoT application, Internet of Things and Internet of Everything, in association with the robotic technologies, which have impacted the industrial sector, the business sector, even if it is going to impact the service sector in a large way, in a large form in the day to come. And when we are talking of the industry 4.0, so definitely the core technology that IoT, Internet of Things and Internet of Everything, and that we can tell what I have told now, just the integration of the technology. The IoT can be thought of, and when we are talking of the Internet of Things, definitely that had been developed due to the integration of the artificial intelligence, the artificial of networking, artificial intelligence, the networking concept, the embedded processing, embedded computing, and the smart computing and sensor technology. Imagine how many technologies has got integrated for the providing the application platform of the industry or IoT in the Internet of Things. And the Internet of Everything, that is the extended form, and which will provide not only communicating from machine to machine, but also communicating from machine to man and man to machine. And as a computer scientist, I visualize it will also providing the abilities from computer communicating from man to man with the telepathy concept, and in future that might be extended, how this communication can be established from a man to the animals, animal to man, and animal to animal, and all these things can be possible. I do think by the impact of this in the future days, the animal mind also might be intelligent, and the creatures might be intelligent, and everything might be intelligent. And its vigorous application, what is going in today, that everybody is knowing. By the end of 2020, more than 26 billions of the devices have been connected under the IoT, and more than 50 billions of the devices have been connected and empowered through the internet. And in a vigorous way, that is going to be impacted, and it will be, the enhancement of this concept will be there in a multifold manner, in an exponential manner in the future days, when the complete industry will be converted to the smart industry, and the machines will be the smart machines, intelligent machine, and industry and machine will be having the capability with talking with one to another. And suppose a machine engaged in the material supply to the machine engaged in the production, they can talk with one another, they can communicate with one another, and they can schedule the production schedule, they can maintain the production schedule, and all things will be happen. And in that respect, when we are talking of the artificial intelligence, the machine learning, that will come in a great way for making the sound of this and making the IoT and IoE concept more powerful, and in that way it will that IoT and IoE robotic techniques will not only play the vital role in Industry 4.0, along with it will also play the vital role in the Education 4.0, which have been the emerging demand due to the pandemic situation. As Swami Vivekananda has told, every cover is uncovered when it is discovered. Necessity is the mother of invention. Similarly, the pandemic made us compelled to go for the Industry 4.0 and the complete online platform to be there to fulfill the demand and catering the demand of the Sarva Shiksha Abhijan. So whereas the concept are concerned, imagine when you have talked of the Industry 1.0, that was simply the industries and the business sector got empowered by the steam energy. And industry, by the introduction of the electricity, the Industry 2.0 got existence. The electricity energy got utilized for the enhancement of the productivity and efficiency. by the use of the ICT application in the front end as well as the back end application in the industries and the business sector, we had the industry 3.0. And what is now today, that means that will be the industry 4.0. That will be the fusion of all the physical devices, all the digital devices, and all the biological devices. The fusion of these three kinds of devices, digital devices, physical devices, and biological devices, will provide the great acceleration of the speeding of the industry 4.0 in the future days to come. With these words, I don't want to talk much because our honorable speakers are there, our learned Vice Chancellor is there, and our people, our participants are there very much eager to listen to them. I want to conclude my speech. Once again, welcoming each and everybody, and once again, praying to the God for the benefits and for the betterment of all the participants who have joined here. And I do believe at the end of this international webinar, our participants will be returning with a very huge content and good content in their mind, and so that their knowledge and their level of knowledge might be updated. I pray to the God, may God bless each of the participants who have been here to pick up the daffodils from the paradise of their future career. Thank you, everybody. Namaskar to everybody, and have a very good morning and good day. Thank you. Thank you very much.
Thank you so much, Nayak sir. You just show the path for this webinar, how we will proceed today's webinar. So thank you so much, sir. And now it's a time for our inaugural address by the chief guest. And our today's chief guest is none other than Dr. Narendra S Chaudhari. Dr. Narendra S Chaudhari is working as the Vice Chancellor of Uttarakhand Technical University, Dehradun, and he has also been with Indian Institute of Technology, Indore since August 2009 as a professor of computer science and engineering. He had been director of Visvesvaraya National Institute of Technology, Nagpur since June 2013 till June 2018. He had additional charge of director of Maulana Azad National Institute of Technology, Bhopal from March 2016 to May 2017. Mr. Narendra was the part of 6-member academic delegation of a state visit of Honorable President of India to Sweden and Belarus for the duration of 31st May to June 4, 2015. Further, he was also the part of academic delegation of a state visit of Honorable President of India to People's Republic to China for the duration of 24th May to 27th May 2016. Mr. Narendra has soldered many senior level administrative positions in universities in India as well as in abroad. He is having 361 numbers of publication with this name. And with these words, I like to welcome our today's chief guest, Mr. Narendra Singh Chaudhari sir, for the inaugural address.
Good morning. Can you hear me?
Yes, sir.
we can
Good
hear you.
morning.
Can you see the slides?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Everything is perfect.
Right. Professor A.K. Nayak has already covered, in fact, in his speech, a lot about Industry 4.0 and also the revolutions. What I thought I can bring into this august audience, consisting of Professor Dharam Singh Jat, my old friend, Professor Ratnadik Deshmukhji from Aurangabad, and now playing a leading role in the CSI, Dr. Santhil Kumar, Sumant Bhattacharya, Mukesh Kumarji, who will be giving us the practical aspects about Industry 4.0 in the Steel Authority of India. And I suppose that would be a interesting talk. And in the presence of such audience, august audience, particularly now I am concentrating more as a Vice Chancellor on the spread of the technical education. So I did not really go through the details of this Industry 4.0 from the point of view of the technology and from the point of view of the research advances, industry advances in this particular aspect. So I'll be talking little bit about the general aspects and will try to end my talk with some comments on the impact and how we should possibly change, possibly make the changes in our technological education. All of us already know that the national education policy has already been announced. What is now underway is the research and innovation policy. And the way I look at it, the industry 4.0, the amalgamation of artificial intelligence, the as Professor Nayak has already mentioned, communication between various devices, various aspects which involve the physical devices, which involve the communication through IoT and also the biological devices. So this is something, the integration and amalgamation in the tomorrow's factories. This concept has already been introduced much earlier in this decade about Industry 4.0, and I thought that it is in the proper perspective to look at what are the mega trends, the industrial revolution, first industrial revolution, as has already been mentioned by Professor Nayak. Okay, this began in the Britain in the last quarter of 18th century with the mechanization of the textile industry, harnessing of the steam power, and the birth of the factories. So this was based on the steam and power production system during 1800 or so. The second revolution began roughly a century after the first and peaked at the beginning of the 20th century. It embodied Henry Ford's creation of the moving assembly line, and that ushered the mass production. So interestingly, there is a quote, interesting quote, that since it is a mass production and the factories can produce countless identical products, there is a famous Ford's famous line which says that he can sell customers cars of any color so long as it is black. Interestingly, what it means is essentially the identical products, okay, can be mass manufactured in a very cheap way. That is essentially the characteristic of this industry 2.0, which is based on the electric power production, okay, during the 19th and the earlier part of the 20th century. The third industrial revolution, industry 3.0, we might say, it started beginning 1970 when computerization, the digital devices, applied electronics and information technology was available, and this was applied to the processes of the production. Particularly, it involved something like additive manufacturing, mass customization, and the components like 3D printing. These were the key concepts and its applications. And this, in the third industrial revolution, is still underway, because if you look at Indian context and Indian scenario, we are in fact using a lot of aspects about these things, and particularly for the advanced manufacturing processes. See, these aspects we are using. See, this is something, okay, which is not really my slides, but okay, these are certain things which I collected quickly from the web. So this industry 3.0, based on the electronics and computers, and in fact lot of such kind of automation could take place In fact, it has taken place, and we can now see that it is used. Now it is the fourth industrial production revolution that we are talking about, and Industry 4.0 is, in fact, I could say that okay, it is conceptualized as an upgrade of the third revolution, and it is marked by the fusion of the technologies which uses physical, digital, and biological worlds, which has been mentioned by Professor Nayak as well. So particularly, okay, it is based on what we might like to call it as a cyber physical systems. And this cyber physical systems essentially involves this amalgamation of various aspects. So this is essentially, as I said, physical, digital, and biological worlds are to be amalgamated in this way. So this is a pictorial view. Again, it's a steam, which in fact was a key idea in the first revolution. Electricity was a key idea in the second industrial revolution or industry 2.0. Computing was the key idea in industry 3.0, and now in industry 4.0 what we are doing is the amalgamation of various aspects, which we might like to call it as the fruits of AI, machine learning, and the technologies, related technologies, and the advances in the communications. So this 4.0, fourth industrial revolution, known also as industry 4.0, okay, would combine various aspects, IoTs, Internet of Things, robotics, etc., are the core of this fourth industrial revolution. Now, when I say artificial intelligence, okay, what are the aspects, okay, that we are looking at from the conceptual point of view? I suppose Mukesh Kumarji and other experts would be talking much more on the application aspects. Here, the concepts would be AI. Where do we want to use the AI and how do we want to integrate that? Sense making. That is the ability to make the sense of unclear scenario, unclear situation, to define the deeper meaning or significance of what is being expressed. Novel and adaptive thinking, particularly the aptitude of thinking and coming up with the unique solutions and the responses, can how the AI, encoded AI, help us in the complicated scenario. Social intelligence, transdisciplinarity, new media literacy.
Oh, you are here there. Oh,
Hello. Yeah. Cognitive load management, computational thinking. Computational thinking involves the problem solving process that involves the logical organization of large amounts of data and analyzing that by finding out the general patterns. What we now call it as the data analytics, the part of data science. That also would get amalgamated in Industry 4.0. Design mindset, that is the ability to represent and develop the work processes for desired outcomes. The also important aspects like cross-cultural competency and virtual collaboration. I'm happy to see that okay, with the technologies, COVID has already taught us how virtually we can deliver the lectures, deliver the addresses, and also start teaching. In fact, we have already done that. Not only teach the students, but also evaluate them, but also not only just evaluate, but also see that we can clarify the concepts through the media that we have. So this Industrial 4.0 is a concept of blurring the real world with the technological world. And this, in the technologically advanced countries like Japan, USA, China, UK, etc. These things, okay, are now in fact in this race. Lot of things have already been done, and I would say that additive printing, augmented reality, cloud computing, big data, analytics, robotics, AI, gene editing, simulation, sophisticated centers, and many other technologies are evolving as a drivers of this industry 4.0. Interestingly, in education, technological education, led by All India Council for Technical Education, we have introduced in our BTech curriculum, undergraduate technological curriculum, many such specializations like augmented reality, cloud computing, big data analytics, robotics, AI and machine learning, and related aspects, including drone technology and so on and so forth, which in fact does include lots of other aspects in which would drive this industry 4.0. Uh, in fact, in the beginning of this century, one of the DARPA challenges, the defense agency in the America, they in fact pose these challenges that can we have a driverless car? Today, the driverless car has become a reality, and this driverless car has been tested for driving automatically with the, in fact, I would say almost nil intervention of the human being from the east coast of America to the west coast of America, okay, which is about 4,000 kilometers of road. And on such kind of roads, this has already been tested. So we already know that this technology is now already available. Connected handheld devices, I mentioned about the augmented reality and so on and so forth. So we talked about a smart, in fact, this leads us to the smart factory that is characterized by the ecosystem of Internet of Things, where every factory operation is connected through the internet. So this is about the industry 4.0. If there is a time, I thought, okay, I would show you few videos which I have downloaded from the website. And one video I would like to show you is about the video of Singapore, how in Singapore, where I worked for about 9.5 years, Singapore has their research agency which drives the new trends in the technology through their research, something similar to our Department of Science and Technology, DST in India. They have equivalent of the DST, which is called as the A star. And this A star as a science and technology agency, Advanced Science and Technology Agency of Singapore, okay, they have in fact worked on the industry 4.0 various aspects. As in Germany, digital, this Bosch plant at Germany, what are the components of that thing? So there are some videos. I thought that, okay, I'll share few aspects of these videos with you. Not very sure whether I can quickly share the slides. Yeah, I'll try to see whether I can. Yeah, that is a new share. And in the new share, yeah, I wanted to share this thing. Can you see my this thing?
Yes, sir.
Yeah. Now I will try to play this. Yeah. And maybe for few minutes I will try to play so that, okay, this makes it, yeah.
You can play it, sir. It will be
Yeah.
played.
I'm not sure whether it is visible. Let me see whether it is visible too.
Yes, sir,
Is
you
it
can-
visible?
A vision of tomorrow's manufacturing. Products fight.
Is it visible?
No, sir, it is not visible. Just do
so-
one thing, sir.
Yeah.
Just stop the presentation and again share, and you can select that page which you want to share. Means you have to select that video.
Okay.
Yes, sir.
I need to select the video. Yeah. Right.
First, we have to stop this presentation, sir.
Is it?
No, sir. I am just stopping it out.
Yeah.
Now you can just share it again and select that video, sir.
In their way
Can you see them?
Yes,
to
yes,
the
yes. Now
production
fine, sir.
process.
Yeah.
In
Is it clear?
intelligent factories,
Yes, sir. It is clear.
machines
It's
and
audio.
robots communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized, and resource-friendly mass production. That is the vision for the fourth industrial revolution. Look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first Simatic. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like.
So this was, can you hear me now?
Sir, now the video is stopped.
Can you, yeah, I have stopped it, but can you now hear me?
Yes, sir. We can hear you, sir.
Yeah. So you see, this was the first video, okay, which introduces and it also tells how in the Germany, particularly the collaboration of the industry with the universities is so strong that lot of research is being done in the university campuses. And this is a very fruitful research. You can see that why Germany is one of the very, very advanced countries. I had an opportunity to stay for one semester as a visiting professor in Berlin, and I did visit a lot of campuses in Germany where I saw these aspects. Now what I thought was, okay, I would share with you the second, I will show you the second the video. Of course, this video can go on, and in fact, it tells us that how the research has driven Industry 4.0 in Germany. Now I will share you I would like to share the second video. Right. Okay. So I'll play that. This is something, the efforts of the Singapore government. Essentially, okay, it's a government-led effort, but okay, yeah. So let me see. Yes.
The manufacturing industry has undergone significant revolutions. Now,
New share, and you want me to share this.
Sir, it is already shared, sir. You can just play.
the industry
Yes.
is
Can
entering
you see
the
the-
exciting Industry
Can you
4.0.
see the
Yes, sir.
screen?
Yes, sir.
It is a transition powered by data and automation technology that could transform every step of the manufacturing process, from the supply chain and enterprise to the shop floor and end users. The goal is to drive productivity and innovation and empower businesses in an integrated, data-driven manufacturing environment.
Asia is now occupying or has in fact taken more than half the global share of the economy. And with that, global companies have started to base not just manufacturing but even local product development and designs within Asia in key locations, including Singapore. We do see that the need to move up the value chain for manufacturing, the adoption of Industry 4.0 concepts is going to be a lot more pervasive. For the central government, the manufacturing domain is one in which we are very heavily committed in, having committed close to about 3.3 billion Singapore dollars, which is roughly about 2 billion euros, to fund public-private partnership R&D activities between the states through agencies such as A-Star and the private sector in Singapore.
The A-Star Model Factory is an immersive learning environment which allows companies to experience and experiment with advanced manufacturing technologies before adoption on the factory floors. This is a platform for co-creation and co-development between private sector companies and public sector researchers. The Manufacturing Control Tower is the nerve center of Simtek's model factory. The MCT provides visibility across the entire manufacturing pipeline as data is automatically collected, integrated, and displayed through smart IoT technologies. It creates a connected, data-driven manufacturing environment that empowers faster problem diagnosis and informed decision-making. Industry 4.0 also goes beyond using data to optimize operating conditions. The model factory explores the creation of intelligent networks along the manufacturing chain with new technologies like industrial IoT, robotics, and augmented reality. These smart networks transform manufacturing processes like production and assembly, repair and maintenance, as well as help with effective training. For companies looking at new opportunities, new areas, and new locations in the world, Singapore is a good location to enter Asia.
So you see, this was a second. Can you hear me?
Yes, sir, we can hear you, sir.
Yes, yes. So you see, okay, the way the Singapore government promotes the research, you see this Simtek, the tower of Simtek, the huge building, okay, which is about 15 floors, is located within Nanyang Technological University, NTU, which is the only technological university in Singapore. And in fact, I served in NTU Singapore as a professor of computer science and engineering for about 9.5 years. So you see, I had in fact quite a good interaction with Simtek, and you can see now, okay, how this Singapore government has promoted in Simtek this Industry 4.0. Of course, all these things has happened after I left Singapore, but still I'm on the mailing list of Simtek, and I'm still in communication with some researchers in the area of Simtek. Okay, now the first video, okay, which we started with, okay, I did not, in fact, I cut down because, okay, there was some research aspects about it. The third video I would like to play is about the existing Bosch plant in Germany. And I will try to play that now. Yeah. Is it sharing? Is the screen being shared?
Yes, sir. Yes, sir.
Can you see the screen?
Yes, sir, we can.
Video also?
Yes, sir, we can.
Voice is there. Okay. Yeah.
The Internet of Things and Services allows for limitless possibilities. New technologies expedite the creation of revolutionary value-adding innovations. What seemed like yesterday's science fiction is today's reality. The fourth industrial revolution is at full speed. As pioneers of this work worldwide, our strategy is geared towards a digital factory. Our hydroelectric power station generates renewable energy. By combining energy and production data, we systematically improve our energy efficiency. Our digitized in-house special machine building unit paves the way for a fully connected production. The interaction with our machines is as intuitive as using a tablet. We experience our machines throughout the design and construction phase. To achieve this, we make use of virtual reality. Our holistic strategy towards a digital factory ensures the utilization of future-oriented technologies. To this end, we develop processes that will shape the world of tomorrow. The complete automation of our flow of material through RFID streamlines our logistic processes and reduces stocks. Simultaneously, we create transparency along the entire value stream in real time. We're aware of the processing status of every order at any given time. This fosters a highly flexible environment. Furthermore, demand-driven material replenishment reduces the workload of our employees. In our relentless effort to improve, we utilize automatically generated analysis and evaluations. In doing so, we can focus on what's important, the availability of our machines. Failure losses on production lines are made transparent by means of standardized visualizations and address specific target groups. This facilitates a comparison and benchmarking of our machines on a global scale. Trends and critical developments are automatically detected and reported to our operating personnel before output losses occur. We record potential error sources. Relevant video sequences are intelligently edited and subsequently analyzed. Reoccurring interferences are linked to known error patterns. Recommendations for action are derived from these patterns and enable our personnel on site to act as skilled problem solvers. Industry 4.0 also represents flexibility for our employees. Mobile shift scheduling allows a quick and customizable shift organization. In our cafeteria, we experience the advantages of digitization on a day.
You see, this gave us some idea about what has already been implemented in Germany. Can you hear me?
Yes, sir. We can hear you, sir.
Okay. Yeah. And can you see my screen?
Yes, sir. Your
Okay.
presentation is on the screen, sir.
Presentation is on the screen. Okay, fine. So you see, these are some videos which I wanted to share, and from this, yes. What do we want to in fact see now? How India is ready about this. See, there is a lot of in fact apprehension about losing the jobs in the existing factories. I would say that we are not really going to lose the jobs, but the focus is going to be changed. And India's global advantage is in the software services sector. In fact, TCS is now the third largest company in the whole world as far as the software services are concerned. And the focus of Industry 4.0 in combining this traditional manufacturing with the IT and IoT, Internet of Things, could position India as an industrial hub of Asia. So are we really in the other advanced countries where this concept has already been implemented? Can we take up as a leap forward to see that we can in fact do certain things? So Ministry of Science and Technology in our government has already have a program called Promoting and Accelerating Young Aspiring Innovators and the Startups, that is Prayas. That is in collaboration with the academic institutes. IIT Kanpur has already been leading these efforts with other IITs and other technical institutes, financial institutes, and industry to establish the research parks and startup centers. And some of the research parks, particularly the research park in say IIT Chennai, is something okay which has already brought a lot of fruits. IIT Delhi's efforts okay, have already seen the collaboration with the industry. So, to reap the benefits of this revolution, we require the ecosystem which involves the robust digital ecosystem of the investment in the advanced technologies, aligning this digital India and make in India. And how we will be able to do this thing is something okay, which is a challenge. Now, as I mentioned, okay, this kind of focus, change of the focus would create jobs for the millions of our youngsters. Okay. And these kind of jobs are something which are not really today. Okay, we may not be able to appreciate what kind of skills are required. So you see, in the skilling India, what is important for us from the educational point of view is to make them ready for acquiring the new knowledge quickly. So it is not really pushing certain technologies or pushing certain knowledge in their brains, but making them quickly learn how to learn. So learning how to learn is something okay which is important, and this reskilling and upskilling of the workforce to meet the industry requirement remains a challenge as far as the educational institutes are concerned. Now, I would like to show the last video, some glimpses of the last video about the efforts of the Bosch India, which is available. This Bosch India's facilities are available in Bangalore. So let me see whether I can quickly, yes, sorry. Get the, yeah. Can you see this video now, which I'm going to play? Can you see my screen?
Yes, sir. We can see your screen, but
Okay.
still video is not being played.
Okay, video, of course, I'm going to play with now
Yes.
quickly. Yeah. Can you see the video?
Yes, sir. Now we can see.
Voice is
Yes, sir.
clear?
Yes, sir. Voice is also there. Yes, sir.
Okay.
और कार्ड पंच करते ही उन्हें पता चल जाता है कि आज उन्हें किस स्टेशन पर क्या करना है।
इसी वजह से हमको थोड़ा जो भी लॉसेस होते हैं, ऑर्गेनाइजेशन लॉस बोलते हैं उसको, क्योंकि मैन पावर नहीं है, रिसोर्स नहीं है, ये सभी हम ठीक से अलोकेट कर सकते हैं। इससे बहुत बढ़िया बेनिफिट मिला है हमारे लिए। ये जो भी हमको लगता था कि मैनुअल ट्रैकिंग करता था, वो पूरा एलिमिनेट होके ये सिस्टम ट्रैकिंग हो गया है।
इस प्लांट में अंतर्राष्ट्रीय बाजार के लिए कई प्रोडक्ट्स बनते हैं। इंडस्ट्री 4.0 वाले इस प्लांट में ज्यादातर वक्त मशीनें खुद एक दूसरे से संवाद करती और मुश्किल काम को बिना थके लगातार करती हैं। इससे कर्मचारियों को काफी राहत मिली है।
ये तकरीबन 4-4 केजी वेट करता है। उसका तकरीबन उसका मतलब है 8 केजी हमारा एसोसिएट लोड और अनलोड करना पड़ेगा। एक शिफ्ट में तकरीबन 8 घंटे में उनको 1600 बार उठा के लोड करके अनलोड करना है। ये उसके बाद उनको स्टेशन के एक्टिविटीज भी देखना है। ये थोड़ा मुश्किल का काम है, क्योंकि उनका शोल्डर तकरीबन 1 मीटर के तकरीबन हाइट पर लोड करना पड़ेगा। इसके लिए थोड़ा दिक्कत होती थी, उनका शोल्डर ड्रूपिंग होता था, और जो भी स्टेशन में 2-3 स्टेशन में काम करते थे उनको थोड़ा हेजिटेशन था कैसे काम करेंगे। इसलिए हमने सोचा कि एक अच्छा सोल्यूशन निकाले।
लेकिन क्या ऐसे उपाय धीरे धीरे इंसान की नौकरियां खत्म करते जाएंगे? दावोस के वर्ल्ड इकोनॉमिक फोरम की एक बहस के मुताबिक आर्टिफिशियल इंटेलिजेंस भविष्य में 70% से ज्यादा रोजगार इंसान से छीन लेगी। मशीनों का आपसी संवाद निश्चित रूप से समाज के ताने बाने पर असर डालेगा। तो इस डिजिटल ट्रांसफॉर्मेशन के नुकसान को कैसे कम किया जाए?
भारत में इसकी वजह से शायद कुछ नौकरियां खत्म हो सकती हैं, लेकिन मुझे लगता है कि अगर हम ऐसा नहीं करेंगे तो निश्चित रूप से नौकरियां खत्म होंगी, क्योंकि हम प्रतिस्पर्धा में नहीं टिक पाएंगे। मुझे पूरा यकीन है कि अगर भारत में हमने इसे ठीक ढंग से लागू किया तो ये ज्यादा नौकरियां पैदा करेगा। बात सिर्फ ये है कि ये नई नौकरियां बिल्कुल अलग तरह की होंगी और हमें अपने लोगों को इस डिजिटल ट्रांसफॉर्मेशन के लिए तैयार करना होगा।
कंपनी की क्यू एकेडमी अपने कर्मचारियों को भविष्य के लिए तैयार करती है।
So, am I?
Yes, sir. Yes, sir. You are also audible and
okay, I am audible. Okay. So, you see, the need of the hour is well-designed education and training strategy. Of course, Bosch India is doing it, okay, in its own way, in a different way. But this requires, okay, three-pronged approach of developing the social skills, restructuring our technical content, and reskilling the workforce. This also would mean that well-regulated industry mechanism that encourages the application-oriented learning for our graduates. And this is where industry-institute interaction, which we have been talking a lot. But when it comes to actual reality, particularly in the university like our Uttarakhand Technical University, when we have about 100 technical institutes which are affiliated to the university, to what extent our collaboration with the industry for giving the internships for our graduates and giving this reskilling of the students, giving them the perspective is something, okay, which needs to in fact be strengthened. And this needs to inculcate also the social skills like emotional intelligence and cognitive flexibility. And we need to see that the citizens, okay, who are capable of contributing to the society. To this particular end, AICTE has taken up the efforts to restructure our curriculum, which includes the part of our curriculum as a course on human values. So these government initiatives such as Make in India, Digital India, Skill India, Atal Innovation Mission, Atal Incubation Centers, and Atal Tinkering Labs, this will play very important role in this bridging the gap between the current and the expected ecosystems as far as these aspects are concerned. So I would like to end my presentation by just showing you the skills required, various skills required, okay, particularly the computational thinking, design mindset, okay, cognitive and load management, social intelligence. These are certain going to be very important aspects as far as these skills are required. This is another slide which I have taken from World Economical Forum, okay, which in fact how things are getting shifted very quickly, particularly complex problem solving, critical thinking, creativity. These are becoming on the top of the skills that our graduates need to have. So our structuring of the educational curricula and the delivery of the materials in our 4-year BTech program should be of such a nature that in addition to the domain knowledge that we give, say in mechanical engineering, electrical engineering as specialized areas, these aspects about the complex problem solving, critical thinking, creativity, these are going to be very important. Also the people management, emotional intelligence, decision making, these remain important aspects. And you say, okay, when it comes to this, uh, you see these skills, okay, are something that we need to in fact keep in mind as far as the design of our curricula is concerned. UTU has already taken the steps, so our university has already taken the steps to see that the curricula have been restructured, okay, to incorporate these aspects in our evaluation processes as well. So just as an acknowledgement, this material, nothing is of my original thing. it is taken from various books, reports, internet, Wikipedia, and so on and so forth. And if there are some other sources, okay, this is unintentional as to I could not list all of them. Thank you. And I suppose whatever time was allotted to me, I think I might have exceeded a little bit. So, Professor Nayak, thank you for giving me the opportunity for interacting with all of you. Thanks.
थैंक यू वेरी मच सर.
Yeah.
थैंक्स तो हम लोग को देना है, तो हम तो जस्ट आई कैन मेक ए कॉम्प्लीमेंट. ना हर रात को चांद नसीब होता है, ना हर रात को चांद नसीब होता है, ना हर इंसान को मंजिल प्राप्त होता है, ना हर इंसान को मंजिल प्राप्त होता है, ना हर समारोह में आपका और धर्म जी का जैसे वक्ताओं का उपस्थित होता है. This is just a compliment. And in what a nice way you have presented the concept of Industry 4.0, very fundamentally, very conceptually, and very technically, and supported by so many excellent video. And I have also learned a lot of things from that. One of your video that I have seen, that it has been told that perhaps in India, many of the jobs might be lost due to the implementation of Industry 4.0. And question is there, answer is also there. Yeah. Because in India, our philosophical concept to make the digital transformation, not to replace the manpower, not to replace the jobs, rather to enhance the productivity, efficiency, and effectivity, so that more and more funds can be generated, which can be diverted in setting up more and more industries, which can be diverting for setting up more and more entrepreneurial organizations. That is our concept, that is our things. And I have got a lot of things that you have told. What is how the interlinking is between Industry 4.0 to Education 4.0. Rather, I can tell like that. Yeah. Industry 4.0 might be the cause, and Education 4.0 might be the effect. Because today, when we are talking of the Education 4.0, we need the complete digital transformation in the education sector. So definitely we will be needing of building of the virtual lab, virtual university, and all these things, where this Industry 4.0 can play the most vital role. And what you have advised, and a lot of things I have also learned, and what is the inputs that is being given in the new education policy, and what is the framing the AICT. Sir, for your information, let me bring before you, I got a lot of things from this, which will be helpful for me, because at present I am a member of Board of Studies of Computer Science and IT of AICT, and given the charge of convenorship of framing the 2-year MCA syllabus. And there, whatever the input I got from your speech, many of the things to be incorporated, what you did in previously. So there are a lot of very valuable, very vital information that we have got, and definitely it will be also very much helpful for our participant, because the thing is that what you have told, that the internship, education and industry and academia interaction, that the students will be getting the internship under the platform of the Industry 4.0, and that is and you are preparing in a massive way, or through your hundreds of the technical institutions, how they can exploit the facilities and opportunity to be with the industry for the entrepreneurship or for the internship program and getting the thing. That is the main thing. The student must have got the idea. That means they must have got, this is the time actually, that is the time to unlearn, learn and relearn. The old concept might be out, and learning should be there, and relearning and updation and acquisition of knowledge should be a continuous process. I must have to advise the student community who are present here, what you have learned, listened today, just you don't forget it, because people tell that if you listen, you can forget. If you read, then you can understand. And if you practice, then you can realize. So try to keep in mind of the three concepts. And such so excellent deliberation you made. We are really thankful. We are really grateful on behalf of our managing committee and behalf of our group of institutions. And we express once again our billions of gratitudes and millions of thankfulness for your gracious presence and delivering this wonderful inaugural address. Thank you very much, sir. Namaskar.
Thank you so much, NS Chaudhary, sir. And It was a really nice presentation by you, sir. As we already just seen in the chat box also, each and every participants are congratulating you, sir. And thank you so much, sir. So now we will proceed towards our next session, that is keynote address. And for that, I like to welcome Professor Dharam Singh Jat. Professor Dharam Singh Jat received his master's degree in engineering and PhD in computer science and engineering from prestigious universities in India. He is a professor of computer science at Namibia University of Science and Technology (NUST) from 1990 to 2014. He has he was with the College of Technology and Engineering, Maharana Pratap University of Agriculture and Technology, Udaipur, India. He has guided about 8 PhDs and 24 master research scholars. He is the author of more than 146 peer-reviewed articles and author or editor of more than 16 books. His interests span the areas of multimedia communication, wireless technologies, mobile communication, system age, roof computing, software-defined network, network security, and Internet of Things. He has given several guest lectures, invited talks at various prestigious conferences. He has been the recipient of more than 19 prestigious awards, such as Eminent Scientist Award, Distinguished Academic Achievement, Eminent Engineering Personality, CSI Chapter Partner, CSI Significant Contribution, Best Faculty Research, Best Technical Staff Outstanding University Services Award, and Distinguished ACM Speaker Award. So with all these words, I like to welcome our today's keynote speaker, Professor Dharam Singh Jat sir, for his address.
Thank you, Prof. Rohit. Can you see my screen now?
Yes, sir.
Yes,
sir, we can
yes,
see your
exactly. Clear.
Yeah. First of all, I would like Honorable Vice Chancellor, Professor N S Chaudhari, Professor A.K. Naik, Professor Rohit Kumar, Professor Desmukh, industry expert Mr. Mukesh Kumar. First of all, I would like to thank to Professor A.K. Naik and Professor Rohit Kumar for giving me this opportunity. As Professor Naik already gave the introduction, as well as Professor Rohit already gave my introduction about where I'm working right now. I'm working in Namibia University of Science and Technology in the computer science department. So before my technical presentations, I would like to share something about my university and some activities. And some of presentations, some of participants asked about the country, so I have included some presentations regarding the visiting place in Namibia and various initiatives. So Namibia University and Science and Technology, the vibrant institute of higher learning, with approximately 11,000 students enrolled, with which about 650 are international students representing 32 countries and 4 continents, including India. So we have 3 PhD scholars also from India, and 2 are from IIT, and 1 is from NIT. Just as Professor Naik already mentioned, that the University of Namibia University of Science and Technology, where I am working, we submitted the project for UNESCO Chair in Smart and Secure Environment. Just a minute, please. And the domain that we will work in these domains are the smart communications, big data, infrastructure analytics, as well as the cyber security. And that particular award we may receive 4 years or 5 years, even though the MOU is pending with UNESCO, and we are expecting the MOU from in February or sometime in March from UNESCO. Namibia Institute of Science and Technology is situated in the city of Windhoek. City of Windhoek is the capital of Namibia. There is another university, is University of Namibia, that is also situated in Windhoek. These 2 universities are the public universities. And my wife is also working in the University of Namibia. She's professor in psychology. Some visiting place you see here, you see the cultivation of the oysters in Namibia. And this is Swakopmund or Walvis Bay, where we see some desert and similar situation like Jaisalmer in Rajasthan in India. This is another important place, Sandwich Harbor. Here you can see the sand of the stream or dunes and the sea are made together. I think this is the one place in the world. This is only one place where we can see. In left side there is a stream of sands. In right side there is a stream of water. And this is Walvis tree is also especially in Namibia only. Swakopmund, we have some Indian initiatives. This is the IAM Starkas, visited 2 times in Swakopmund. Some of the Indian community also invited during the dinners. Some movies are also shot in Namibia. You see, this is Ghazni Bollywood in Africa, and in Namibia, the place is Sosanfile. In 2016, this is a historical moment that Honorable His Excellency late Sri Pranab Mukherjee visited Namibia Institute of Science and Technology in Namibia during June 2016. In this one, you see some photos, the minister, education minister in Namibia, or former vice chancellor, and some dignitaries from Namibia, and faculty and another dean and director from Namibia Institute of Science and Technology. So during the visit, the government of India as well as government of Namibia signed to establish the Center of Excellence in Namibia Institute of Science and Technology. And now we established the Center of Excellence and waiting the inaugural from the President of Namibia as well as dignitaries from Indian side. On 24th November 2020, His Excellency, the High Commission of India to Namibia, Mr. Prashant Agarwal visited the center. You can see this is the India-Namibia Center of Excellence IT. Here you can see the map of India as well as the Namibia. And our acting deans and other staffs and deans and the dignitaries from the embassy. Now we are waiting for the inaugural for the center, and center is working in 2 parts. So this is especially I mentioned the slide for this presentation because now we are working for Industrial Revolution 4 and we are moving toward the Industrial Revolution 5th. And for this one, this is particularly we established the HPC research in Namibia Institute of Science and Technology, and we gave the name is HASPERM and HASHERB. PERM is the Namibian name, sorry, Indian name, and HERB is the Namibian name. So this HPC computing system and the name is the PERM and HERB, and we will use for the computing part, storage part, for the complex data. And there is another slides that I mentioned for you. This particular HPC will have a different nodes, and the nodes is based on the AI edge computing, artificial intelligence edge computing, that I will explain what is the need of artificial intelligence edge computing, because now we are Industrial 4. And Professor Chaudhary already explained about the history of the Industrial Revolution 4 and other aspects, the Industrial Revolution 4, but we have to prepare for the Industrial Revolution 5th right now. And these are the nodes, 4 nodes based on the edge artificial intelligence. I will explain later on what do we mean by the edge artificial intelligence. I'm also the IEEE DSP. So if someone is interested, can also apply IEEE DSP. I'm also the ACM distinguished speaker. And if you are interested, you can also apply here. And if you are participating on behalf of IEEE ASP, then IEEE or ASP will pay the international cost for your travel. Now, on the past few decades, a 4th industrial revolution has emerged, known as Industry 4, as Professor Chaudhary and Professor Naik already said in his inaugural lecture. Industry 4.0 takes the emphasis on digital technology from recent decades to the whole new level with the help of interconnectivity through the Internet of Things devices, access to real data, and the introduction of cyber physical product system, as Professor N.S. Chaudhary already explained about the cyber physical system. So in these presentations, I will cover about the introduction part. There are 3 horizons in industry 4, some smart manufacturing, and 3 design principles, building blocks, industry 4.0. I will also give the brief introduction about the IoT, AI, machine learning. So my presentation is based on something is research and innovation part as well as the application parts. So we'll discuss about smart and sustainable cities in terms of industry revolution 4.0. We'll discuss about the edge computing paradigm. So the key essence of industry 4.0 concept is the enhancement efficiency in the process of industry by way the utilization of connectivity, data, or we can say right now the big data, Internet of Things, and artificial intelligence and other technologies. And the 5 characteristics of Industry 4.0 are interconnections, data integration, innovation, and the transition. Industry 4.0 is focused on creating a smart and secure environment in manufacturing process. So the 4th industrial revolution emerged from AI and Internet of Things devices. So the industry 4.0 is focused on creating intelligence product, process, and procedures. So the essence of the industry vision 4.0 is in the Internet of Things, the artificial intelligence right now. We will also discuss about what we need to do for the industry vision 5.0. Computers and automation put together, in particular based on cyber physical production system that integrate communication, Internet of Things, computing, data processing, and physical element, and wherein these systems transform the traditional factories into smart factories. That is the part of Industrial Revolution 4.0. Day before yesterday, I was participating in the World Economic Forum, where 15 special address from G20 heads of states and government and international organizations were organized during the summit. The Prime Minister Sri Narendra Modi addressed the World Economic Forum Davos summit via video conferencing on day before yesterday. And in his presentation, say here is the topic is India has made rapid strides in 4 pillars of Industry 4.0. You see that I captured from Aaj Tak News from my TV. Here it is in Hindi because some of my colleagues is also participating from Namibia University of Science and Technology, especially Professor Sopala. So they cannot recognize this word, but here you see the Industry 4.0 for humanities is also important. So in Hindi, Industry 4.0 भी मानव कल्याण के लिए है. PM Modi in his address at World Economic Forum Davos Agenda Summit says India has made rapid strides in 4 pillars of Industry 4.0 using technologies. First is connectivity, second automation, third one is artificial intelligence, machine learning, and the 4th one is the real-time data, and we'll explain the detail. Industry 4.0 is for human, not robots. We must ensure that technology become a tools for as of living and not a trap, PM Modi said in his address. So artificial is important part, as Honorable Prime Minister Modi said, it is the part of the Indian initiatives. So the fourth industrial revolution technology driven by artificial intelligence are expected to be the fundamental change of the world. So according to this study, in the recent global survey, 63% of CEOs said they believe that all artificial intelligence will a larger impact than the internet. Professor Narendra Chaudhari already explained about the industrial revolution that now, sorry. Industry 4.0 described the fourth industrial revolution through the introduction of modern ICT production. So this is industrial revolution 1.0, 2.0, 3.0, and 4.0, and Professor Chaudhary already explained in the detail. So there are three horizons of the industry 4.0 implemented and the use. First one is the process optimization. Second one is the process flow and quality. And third one is how business model will work. Using the collected data and inside to create a new revenue streams and value of customers based on the available data and based on the artificial intelligence algorithm. Building new production based on insight digitally gathered from the client. Industry 4.0 smart manufacturing system is based on built on the digital revolution, smart and powerful sensors, machine learning, ubiquitous networks, artificial intelligence, labor and energy and cost. Professor Chaudhary already explained if you by the video, if we move towards the artificial intelligence, there is a loss of jobs in the industry. But what we need to do, we need to try to find out the ways. We need to train the existing main existing workers or existing experts for the artificial intelligence, like we did in the banking system in Namibia. So I think there is no issue, and we have a brain. We can train for the new development, and we need to move toward the artificial intelligence. So of course there is a regular intervention or regular training is required required for the artificial intelligence training or other type of technology. Cyber physical system is very important part in addition to the Internet of Things, because now every physical device will be connected with electronic devices, and we need to gather some information from the environment, and this environment need to be converted to the usable data. So the cyber physical system is a collaborative computational element controlling physical entities. CPS are physical and engineered system whose operations are monitored, coordinated, controlled, and integrated by a computing and communication core. They allow us to add capabilities to the physical system by merging computing and communication with physical process. Industry 4.0 has 6 different principles: interoperability, virtualizations, decentralizations, real-time capability, service orientation, and the modularity. These are some building blocks of Industry 4.0, and we have near about 8 or 9 building blocks, including big data analytics, autonomous robotics, simulations, horizontal and vertical system integration, Internet of Things devices, cybersecurity, additive manufacturing, and augmented reality. And some of the parts Prof. Chaudhary already explained by the video. This is particular slides that I gathered from the Gartner strategy. So those are the top 10 strategy technology trends for 2020 to implement Industry 4.0, as well as we need to move Industry 5.0. These are the people-centric, and here is the smart spaces, including empowered edge, distributed cloud, autonomous things, practical blockchain, and now there is no security. Now we have artificial intelligence security. We will explain detail in the next presentations. So the combination of high speed resilience, low latency connectivity, and technology such as IoT, artificial intelligence, and machine learning will enable the transformation towards sustainable development. And Honorable Prime Minister PM Modi already addressed during his keynote address in World Forum that the connectivity, autonomy, and artificial intelligence, as well as the real-time data is very, very important. Some of presentations, some of students asked what is the artificial intelligence, what is the machine learning, what is deep learning. This is just the introduction part about these different three technologies. So the artificial intelligence and the techniques that enables computers to mimic human intelligence using logic, if-then rules, decision tree, and machine learning, including deep learning and machine learning. Machine learning is the subset of the artificial intelligence. It means it's the subset of AI. If we say AI, machine learning also included, and the deep learning is also included. So a subset of AI that includes complex statistical techniques that enables machine to improve a task with experience. The category include deep learning, and the deep learning is also the subset of machine learning composed of algorithms that permit software to train itself perform the task like speech, image recognition, and other type of data. So if you gather the n number of data, you want to apply artificial intelligence, you have to select some data for training and you have to select some data for testing. Then you can apply deep learning to achieve the outcome of your data. Because data analysis is very, very important. We have a data, but the data is not meaningful data. So we have to go for the meaningful data right now. This is just introduction about the machine learning. One is the dependent variable, other is the independent variable, because this is the crop and here is the crop predict. So this is dependent variable, depends on the rainfall, based on the rainfall. Just explain more about the dependent variable again. This dependent variable again that depend on the independent variable, but not vice versa. Brief introduction about Internet of Things, because Internet of Things, data, real-time data. These are the important part to implement the Industry 4.0, and the network of physical objects that contain embedded technology to communicate and interact with their internal state or external environment. Some of the aesthetics you must know about the IoT, Internet of Things devices and penetration in the world right now. So in 2016, 3.3 internet user were available in the world, but it will be expected that at the end of 2021, 4.6 billion internet user will be there. Here is the devices connected. 17.1 billion devices were connected during the 2016, but it will be expected that 27.1 billion devices will be connected in 2021. So right now the population is 7.5 billion. So every people have 2 or 3 or 4 devices. And we need to think about the communication part. We need to think about the computation part, as well as to achieve the meaningful data. And most of traffic is the video traffic. Here you see the 73% traffic is the type of the video. That is another, that here is, you see, this is the global traffic, that most of traffic is 36.38 exabyte will be created by the video. And this is the file sharing data is only 6.3 exabyte data. Audio streaming data will be generated. This one somewhere is here, less than maybe 2 exabyte data. This is another important slides. So the birth of the Internet of Things was on 2009, where one devices will be connected with one people. So, but it will be expected, it's the old slide, it will be expected right now that every people have the 6.58 Internet of Things devices. This is another presentation that I gathered from the Cisco, IDC, and Gartner. So this particular survey estimated that the end of 2020, we have not the new statistics right now. So end of 2020, the 50 billion devices were connected, supposed to connected, because we don't have confirmed data right now. 32 billion devices were also supposed to connected as per the IDC, and the 26 billion devices were supposed to connected as per the Gartner. So if we compare the three different IT researchers, there is a difference, but we consider the lowest 126 billion devices, and the population is near around 7 billion. So the 3.5 Internet of Things devices will have, each people will have 3.6 billion devices. This is another statistics for IoT security. Security is one of the main issue for implementing in industry 4.0 in the industry for a manufacturing process, because security is another important issue. So this is the investment that we have to invest 3,118 million US dollar in 2021 for the security. We know that smart sustainable cities also implement Industrial 4.0, and this more than half of the world people lives in industry today. By 2050, nearly 7 in 10 people will be living in cities. So cities account for more than 70% of global carbon emission and 60 to 80% of energy consumptions. And we need to find out the way for the smart cities, which includes to provide core infrastructure, given a decent quality of life to its citizen, a clean and sustainable environment, and the application of smart solutions. So the smart cities must save resources, be sustainable, and ensure a better life of its citizens. And ICT infrastructure is the foundation of the intelligent worlds. Building smart cities, collaboration with Internet of Things, that is very, very important during the Industrial Revolution 4.0. And all things sensing connected, and that should be the intelligent. So what is the motivation of smart cities, especially for Industrial 4.0? There is urbanizations. You see the waste of water resources we also need to do something for the smart grid or power line. Infrastructure, you can see, you need a smart transportation, smart climate changes in the city. We have some smart solutions, e-governance and citizen services, including these smart solutions. I think due to the limitation of time, I'm escaping some of the sub parts, but I will share later on presentation for you. Second smart solution is smart health and educations, that we already see the telemedicine, and in India many millions patient or many thousand doctors already uses the telemedicine for for the patients. And during COVID-19, we know remote teaching learning is also the very, very important part. And we used the IT resources, and that enabled with artificial intelligence, connectivity, smart connectivity, and including some of 5G connectivity and other type of high bandwidth connectivity. We have some solutions of waste management, water management, energy management, and the urban mobility. These are some key priority area that City of Windhoek in Namibia. City of Windhoek is responsible for these activities, like council, like Nagar Parishad or Nagar Palika or something in India. So these are the key priority areas for smart city initiative in Windhoek, Namibia. And I also learned that in India, some of the cities already identified for smart initiatives, and they are working for the smart cities, especially using by the technology of Industry 4.0. These are the main 4 pillars of smart cities: the Wi-Fi, open data, improving public transport, and reduce resilience to bulk electricity part. That particular meter I included because this meter installed at my home. So this is the smart meter. So we can charge that electricity, or we can buy electricity through mobile phone, online internet banking whenever we needed the electricity. Now the smart city, especially in relation to 4.0, computer, internet, electronics put together can make smart cities. These are the different entities: transportation, railway, police, hospital, traffic, banking, educational institute, and waste management are the part of a smart city. So the emergence of smart cities and Industry 4.0. We know the Industry 4.0 refers to smart industrialized initiatives and better knowledge as the place where new product and technology are manufactured, where smart cities is a podium where these products and technology get deployed. We need to solution for a smart environment. Industry 4.0 creates a flexible, adaptive, smart platform for disruptive transformation and helps to maintain citizens' value, outcome, sustainable financial expansion, and better societal commitment. So the main dimensions of the smart cities, there is smart governance or smart mobility, smart building, smart energy, smart technology, smart industry, smart healthcare, and smart people. These are the some. So every application should be smart, and every application need to talk to each other. For example, if you want to employ the Industry 4.0 in smart cities, and the dimensions have to integrate each other. If your brother or sister or any family members are going to school and something is happening on the road, immediate that school need to be informed, police need to be informed, parents need to be informed, and ambulance need to be informed to get the immediate remedies. That's why we can say the smart cities. And for that integration, we need a smart solutions. Industry 4.0 technologies are autonomous robots, simulations, system integration, Internet of Things, cyber security, cloud computing, additive manufacturing, augmented reality, and big data. And I will discuss more about the security part, cloud computing, Internet of Things, as well as the big data. So the connectivity of smart cities and Industry 4.0 may create world, and it can develop the public and private sectors effectiveness, expand financial benefits, and improve the standard of living. These are the some smart solutions. These are the KPIs. Here you see the setting of the basic priorities, stakeholders, governance, citizens. When we are talking about Industry 4.0 for smart cities, then developing a smart infrastructure, integrated platform, then identified Find and develop a smart city services. These are the KPIs that I already explained. Then define key performance indicator standard and monitoring and ensure accountability and responsibility, data security and electronic fields. So this is the part of Industrial 4.0. Professor Chaudhary already explained about the autonomous cars. Driver, this is autonomous cars, and Google is doing the project for autonomous cars. Here, this autonomous cars equipped with the various type of communication system and various type of sensors. But still, there is a problem. There is a problem of security. So we need to solve if we want to move in Industrial Revolution 5.0. And that we are moving from this 2021 decade. So the security we have to implement it like blockchain or other type of security system. One of my student developed the voice activate detection based home automated system for special need pupils. Now we know during the COVID-19 and the robotic and drones is the very important part for Industrial 4.0. And that robotics and drones uses the Internet of Things or other sensors. So drone can use to fight against the COVID-19. At well tackles a COVID-19 pandemic, we can see the increase in the use of technology to improve the response and social resilience. Drones are being used to transport medical samples, monitoring compliances, social distance orders, as well as the transport consumer goods. I have included one applications that used in drone deployed to sanitize Nizamuddin Makras to the epicenter of COVID-19 outbreak. But still we have some problems in the drone. Now there is a one drone, we are using one applications. If there is a multiple drone, because we cannot create so many drones, because there is a complex computing limitations. If you have many drones, then there is also interface issue. There is also connecting issue. And there is another issue if you want to gather real-time data. And if you want to recognize that persons, because persons can move immediately after a few minutes or seconds. So you need immediate data as the edge. You need to process data and you have to take the action. So we need the edge computing part. So that's why the edge computing is very important. And we have to develop some edge computing based application-based edge computing at the edge. There is another example of drone. Delhi police use drone to monitor the situation amid lockdown during COVID-19. Now, artificial intelligence and the artificial intelligence at the edge in Industrial Revolution 4.0 as well as 5.0 is very important. So the manufacturing sector is in the middle of the historical movement in development, as Professor Chaudhary already said. With the rise of the IoT, data-centric and interconnect, smart factories are quickly become the norm. Edge computing is still essential for smart manufacturing success. So the intelligent edge in the combination of advanced connectivity, compact processing, power and artificial intelligence located near to the devices or that use the generate data. So the industry 4.0 to reach its full potential, however, manufacturer will have to implement edge computing. We can see these are the Internet of Things devices. Here is a fog computing, cloud computing. This fog computing, Cisco coined the term in 2013, but there is some limitations. So that's why limitations in terms of security. That's why we need another layer edge computing at the edge. So everything is in your hand. The future of Industry 4.0 depends on edge computing. And Industry 4.0 can only get so far without transitioning to the edge. If the IoT was the computing step after the cloud, the edge is the next step after the IoT. Without adapting this technology, Industry 4.0 or Industry 5.0 won't be able to progress to its full ability. So this is one of the example of edge computing paradigm and blockchain. I think Prof. Deshmukh is also the part of this presentation, and this paper is published in Computer CSI Computing in previous issue, and he is the editor of the journal. So in this one, what we are explaining, we are developing some edge computing paradigm using blockchain technology. So right now we are moving to the 6th generation, and 6th generation includes the blockchain technology and some others parts that we have not the part of the 5G. So edge computing, especially blockchain technology, this is the processing data of the blockchain technology. That is the layer approach. We have interface, security services, networking, and the data public information sensing system. Now this is important. This is the conceptual model. Even though we are working, one of my PhD students is trying to develop the conceptual model for architecture, edge computing architecture 4.0. In this case, here is, you see, these are the sensors and the devices. Here is the edge node, the fog node, and the cloud and the blockchain. And now you see what is the importance for this particular research. The 5th industrial revolution, now we call it as Industry 5.0, is going to reshape the world economy. It will be based on the amalgamation of wide range of technologies. So Industry 5.0 implies people are working together with intelligent machines and more quickly by utilizing advanced technologies such as Internet of Things, edge computing, especially HPC edge, high performance computing edge, cyber security, and big data. So it will be add a human touch following the 4th industrial revolution and the pillar of automation and the productivity. So these are the some edge computing devices, sensors, or the applications. For example, a person a patient is running on the road. He is in the ambulance. Patient need immediate response. If we will take the input from the cloud, because cloud computing is also the important part of Industry 4.0. So then we need a processing time at the edge, then the communication time, then again processing time at the cloud, and come back again the communication time. So this is the latency. If latency is more, patient may be dying. So this particular model will gives the edge node. So these particular application will receive the immediate response from the edge node, and history need to be transferred to the cloud. And we also try to implement the blockchain for the security part, because blockchain is not the centralized computing. It's a decentralized computing. So that's why these are the more secure. So in industry, the security is very, very important while they are implementing Industry 4.0. So we need to find out, we need to enter in 5.0 industry, and we need to find out the solutions, including blockchain technology and including IoT or other technologies. Now this is the strategy. As you are successful, I have only 5. Only I need 3 or 4 minutes. Are you successful in navigate the intersection of readiness and the responsibilities of Internet 4.0? So according to this study, success of this Industry 4.0 begins with comprehensive holistic strategy, yet only 10% of executives indicate that they have the strategy in place. While a comprehensive Industry 4.0 strategy may not guarantee success, the survey concluded by Deloitte indicates those companies with strategies significantly outperform their peers with strategies. So we need to develop some of the strategies for Industry 4.0. This is related to the technology. So in terms of technology, expected effects of the business leaders anticipated IoT, AI, cloud solutions will have the most profound impact of their organization. You see here is IoT, artificial intelligence, clouds, and this is the impact of different type of technology. So highest technology, this one is the IoT and the artificial intelligence. So we need to upgrade our industry, as well as we already talked about the job loss for the employees. So there is no question, we need to update with the new technology, by the intervention, by organizing training, by organizing some other type of courses for the artificial intelligence. Social impacts make, according to this study, making a profit while positive contribution to the society is the top investment priority, and that 62% executive agrees. So there is no question of job loss. Talent. So that's another question to solve the problem of jobless or something. Ultimately, it takes the talent to put plans and tools into the action today. And the companies need highly skilled, adaptable, and resilient workforce for Industry 4.0. Only 28% CEOs, this industry, this research was conducted by this study from 200 participants from 15 different countries. So 28% CEOs completed agrees that their organizations have to skills need to success in this era. So we need to have more work. There is a training and developing workforce here, 74%. Understanding what skill will be needed, 59%, and 28% is attracting and retaining the right talent. So the conclusion of my presentations, the connectivity of smart cities and Industry 4.0 may create huge opportunity to join the physical and the digital worlds, and it can develop the public and private sectors effectiveness, expand financial benefits, and improve standards for living. So the intelligent edge is the foundation of future digital business. So edge computing includes the artificial intelligence also. Its ecosystem, and by bringing powerful computing capabilities is closer to the edge, where data originate and processed with machine learning, helping to accelerate the fourth industrial revolution, and we need to move towards the industrial revolution fifth. Edge computing is still early stage and have potential to discover the way for more efficient computing technology to enabling the future or industrial revolution 5.0. Machine learning and edge computing devices also includes robotics, drones, and contribute to fight emergency systems like COVID-19, especially early warning disaster systems, social contact, and image recognition. Thank you. If there is any questions, you can ask. And I would also like to thanks to Professor Naik as well Professor Royce for giving me this opportunity. Thank
you. Rohit?
Yeah, thank you so much, sir. Thank you so much.
Any question? Any question?
Yeah, I'm just inviting the question session for the participants. So the participants, if you are having any questions, you can just type it in the chat box. Still, we are not having any question.
you. Thank you. Thank you.
Yeah.
Thank you very much. Thank you very much, Dharamji, for your kind gesture and for your gracious presence here. You actually delivered a very excellent and insight talk that has helped the participant a lot. In your presentation, you have discussed about the introduction, concept, architecture, and applications, along with the future prospects and whatnot. And mainly, whatever the things what you have given, you have thrown upon the light. You have thrown upon the light regarding the smart computing, regarding the IoT, fog computing, edge computing, and overall the thing is that connecting the IoT as well as the industry 4.0 to the smart cities that India is going to have. So really this talk was very excellent, and there is no doubt you have also ultimately discussed about how the artificial intelligence, machine learning, and fog computing and drones and IoT, all these things will be helping also to combat the COVID-like situations, and how these will be helpful for tackling these kinds of disasters in the future day to come. Thank you very much for your excellent deliberation and for your kind patronage to the different seminar and conferences, webinars are organized by us in virtual mode, and particularly to the Computer Society of India and the Indian Institute of Business Management. On behalf of the Indian Institute of Business Management and its managing committee, as well as students and staffs, I express my sincere gratitude and thankfulness for your gracious presence here and delivering such an excellent keynote address on this occasion. Thank you very much. Thank you very much.
Thank you, bro. Thank you.
Yeah, thank you so much, sir. And with this, we will move forward, and it's a time for invited address. And I think Naik sir, Mukesh sir's network is a little bit low, and he's still joining, sir.
Still joining?
Yes, sir. He had joined multiple times, but due to network congestion, he left
you
the
advise him just show his face, and then he should. You tell him he show his face, and after that he should make his video off.
Yes, sir. I think Mukesh sir is not joined now, sir.
Let me call him. What is the problem with him?
Namaskar.
Sir, I am just calling to Mukesh sir for making the connection.
Okay. So you wanted me to
unmute. Chaudhary sir has joined till now.
Right. I am there.
Yes.
Nayak ji, I am here.
Thank you very much. Thank you very much for your so kindness and attending the webinar full time devotee to this webinar. That's a great.
But I am doing some my office work also parallelly.
You are working in parallel mode. Office work is going on as well as attending the webinar also. And what is the problem of the Mukesh? Let me see. Okay. And when you will join, you will tell him that he will make his camera off. Just he show his face once to the people, then he makes his camera off. This today you invite Deshmukh Sahib for delivering the concluding address.
Sure, sir.
Thank you, sir.
Thank you.
So, dear participants, we are still trying to connect with our another dignitary, the invited addressee, Mr. Mukesh Kumar, who is the manager of Steel Authority of India. So we will wait
General Manager.
General Manager, Steel Authority of India.
Officer.
Yes, sir. So we will wait for another 2 minutes. Yes, now Mukesh sir is now joining with us, sir.
Huh?
Yeah, now he is joining.
Join, na?
Yes, yes. Mukesh sir, please unmute, sir. Yes, sir. Sir, can you hear my voice, sir? Mukesh
Yeah,
sir.
I can hear your
Yeah,
voice.
sir. We can just turn off the camera so that we will use the less network bandwidth.
But at least he should show your face once.
Yes, sir. You can show your face once and then you can turn off your camera, sir.
Yeah, that is true. That is true.
will
That
better
is true.
Yes.
Let me share the screen.
Sure, sure. So now we will proceed towards our next session, that is invited address, and for that I like to welcome Mr. Mukesh Kumar. He is a General Manager of Steel Authority of India. Mr. Mukesh joined as a management trainee in the SAIL, that is Steel Authority of India, in 1985 at Bokaro Steel Plant.
File manager में जाओ.
Subsequently transferred to Bhilai Steel Plant and was there for 3 years before being transferred to SAIL, Ranchi, as in-house consultancy group of SAIL. He has a wide experience in the field of computerization, information technology, instrumentation, and automation. He played a big role and provided consultancy in the computerization and automation of SAIL in general and his unit in particular. Presently, he is working as a general manager and in charge process control and automation at CET SAIL Ranchi. He was already secretary of CSI Ranchi chapter from 2014 to 2016. Under his leadership, Ranchi chapter has bagged Best Chapter Award in the Eastern region in the year 2014, 15, and 2016 also. Sri Mukesh Kumar, as Secretary CSI Ranchi chapter, has organized a mega event Udan 2015 in Association Department of IT, Government of Jharkhand for interstate IT talent search, participated by 22,000 students under class from 12 from rural and urban area of Jharkhand. The winners were facilitated by Honorable Chief Minister of Jharkhand, Sri Raghuvar Das, on 15th of November 2050 in Asthapna Divas of Jharkhand. So, with all these words, I like to welcome Mr. Mukesh Kumar for invited address.
Mukesh ji, not hearing perhaps.
I think Mukesh sir, mic is muted. Yes, sir.
Mukesh ji,
sir, please unmute now.
हाँ, okay.
एक बार तो आप अपना चेहरा दिखा दीजिए वीडियो ऑन
हाँ,
करके.
ठीक है सर, स्क्रीन शेयर है ना, अभी दिख रहा है ना?
Yes sir, your screen is
स्क्रीन तो देख रहा है, बट आपको लोग एक बार तो देखे कम से कम.
हाँ नहीं, that is true sir.
यस, अभी देख लिया आपको सब, क्योंकि आपका वीडियो ऑफ होगा तब आपका स्पीड ठीक रहेगा.
हाँ, अभी थोड़ा स्पीड में प्रॉब्लम आ रहा था, इंटरनेट कनेक्टिविटी में प्रॉब्लम आ रहा था.
नहीं, यू कीप योर वीडियो ऑफ, तब ठीक रहेगा.
Okay, fine. Screen is there shared?
No.
Yes sir, now it is being shared.
Yes.
The screen comes?
Yes sir.
Yes.
Okay.
Make the screen larger, Rohit.
No sir, we can't make it from here, and I request the participants, if you want to larger the screen, you can just zoom in to your screen. The screen will be automatically make it large.
Actually, I was trying through laptop, but there was some problem of internet connectivity.
Yes,
and
there no problem. There no problem.
We can proceed.
So actually, these are slides, but somehow it has opened in WPS Office, so it's like a Word document. Anyway, I will go ahead with this. Respected Professor A.K. Nayak, advisor IIBM, and the past President Computer Society of India. Dr. Narendra S Chaudhari, Vice Chancellor, Uttarakhand Technical University. Dr. Dharam Singh Jat, Professor and the Department of Head of the Department of Computer Science, Namibia University. And Professor Rohit Kumar, Professor Pandey, I welcome you all in the webinar for Industry 4.0. And equally, I am privileged for having given this opportunity to speak few words and share my thoughts. We have heard a very technical aspect of Industry 4.0 from our three distinguished speakers. But I would like to present before you the case study. Now, the real implementation has to come over there. So the implementation of Industry 4.0 in metal and mining industry, and especially in the iron and steel industry, where I'm working in as General Manager, Automation, Steel Authority of India Limited. So I would like to share with you my perspective of implementation of Industry 4.0 in metal and mining industry in general, and iron and steel industry in particular. You know, the metal and mining industry is a very complex sector which is intrinsically linked with the world economy as a whole. But if we talk about the iron and steel industry has witnessed a rapid growth in production capacity for the last 2 decades. You'll wonder to know that between 2000 and 2014, the crude steel global steel production was almost doubled from 800 million ton to 1600 million ton. And in the year 2019, it was 1869 million ton. So you can imagine the rapid growth of steel production. And the major contribution has come, of course, from China, where infrastructure development was in a rapid speed for last 2 decades. And you'll be surprised or pleased to know that India is second in the world category. It was followed by Japan, United States, Russia, South Korea, Germany, Turkey, Brazil. Brazil stands at 9th position with 32.2 million ton of crude steel. Now, when it comes to adoption of any new technology, it's unfortunate that metal industry doesn't take the lead role, because it has been proved that it has become it's very slow to adopt the new technology because of its complicated process. It cannot do it immediately as it can happen in other industry. But however, in the past few years, the pace has picked up. My presentation insight is like this. I will start with what is Industry 4.0 that has been elaborated by all of my distinguished speakers earlier, and then the 4 wing of Industry 4.0, especially with respect to implementation in the steel and iron and steel industry, IIT, IIoT, then artificial intelligence, then machine learning, cloud computing, cyber physical system, augmented reality and virtual reality, if time permits. Then the status of Industry 4.0 in steel industry, but with particular reference to sale, and then our endeavor for implementation of Industry 4.0. As far Industry 4.0 in the manufacturing industry is concerned, it is agglomeration of IT and OT. IT is information technology and OT is operational technology. So if you go by this kind of terminology, then the agglomeration and the combination of IT and OT puts you in a place where you can think of Industry 4.0. The convergence of IT and OT has led to the emergence of industrial competition and industrial automation, called Industry 4.0. Now, with respect to manufacturing industry, there are only 4 wings which we can think of as Industry 4.0. One is starting from IoT, IIoT. IoT means Internet of Things, and IIoT is Industrial Internet of Things. And then artificial intelligence, cloud computing, and machine learning. Now, as our previous speakers has already said, that Internet of Things is the network of physical objects, things that are embedded with sensors, software, for the purpose of connecting and exchanging data with other devices and systems over the internet. If you extrapolate this in industry, then it will become industrial Internet of Things. If you take the example of IoT, then many implementation has been done with ABB, Airbus, Amazon, Boeing, Bosch, Caterpillar, Hitachi, and Stanley Black and Decker. Many places IoT implementation has been done. If we talk about the household IoT applications, our previous speakers, distinguished speakers, has already said that how you can implement this IoT back at home, because with the conversion, with the migration from IP version 4 to IP version 6, you will have 340 trillion IP addresses. You know, the implementation, of course, migration from IP version 4 to IP version 6 is very slow, but sooner or later we have to do it. In that case, each and every intelligent device, active device in your household would have IP addresses. And if these can be linked together, this can be made use of it. It is nothing but Internet of Things. And as our previous speakers has already said, that you can have everything you can think of on your tab, on your laptop, or on your mobile devices, like starting from refrigerator to the geyser, to doorbell, to CCTV, to whatever you can think, and you can control complete house from sitting from the office. That has already come into the being, but of course the area is getting enlarged day by day. Now this industrial Internet of Things. The definition is like this. IoT, I just read out. The industrial Internet of Things refers to interconnected sensors, instruments, and other devices networked together. This connectivity allows for data collection, exchange, and analysis, facilitating improvements in productivity and efficiency, as well as other economy benefits. Now, I would like to slightly, some of the terms may be new for you, may not be new for everyone, but new for you. It is talking about the sensors, interconnected sensors, instruments, and other devices. You know, in any process industry, you have many sensors and instruments like pressure transmitter, flow transmitter, temperature transmitter, weighing system, then many other systems, instruments are there. But if these instruments can be clubbed together, and if we could take it to a PLC or DCS or any computer server, and if you run analytics over that, then probably it is going to tell you that when that equipment, what is the life of that equipment, residual life, and when it is going to fail, so that you can take the corrective action in time in order to save the downtime in the future. You know, we are plagued with the problem in steel industry, in the steel authority of India steel plants like Bokaro, Rourkela, Durgapur, Bhilai. If you are aware of the steel process, it starts from from iron ore, and it is being the mixture of many minerals. It is being used as to produce pig iron. Then it is being converted to crude steel. Then it goes to the caster shop, where it is cast between amongst slab, billet, and bloom. Then it goes to rolling mill, where it is being rolled, where we can have cold rolled sheets, hot rolled sheets, then plates, then rail. You'll be pleased to know that SAIL is supplying 98% of rail for Indian Railways. So we produce rails. Then there are so many products of steel SAIL. So each areas that I have talked about has got process inbuilt into that, and all the processes are having the sensors and instruments, and all the data, 4 to 20 milliampere analog signals, or 0 to 10 volt digital signals, if it is being brought to PLC, which is nothing but programmable logic control, or DCS, which is a distributed control system, where the ladder diagram are being run, and then it is finally being taken to the server, where mathematical model level 2 model is being run, where it says that how to control a particular application. Okay, fine. I will just read out. While connectivity and data acquisition are imperative for IoT, there are foundation and path to achieve manufacturing excellence by adding on further application of all the technology. Predictive maintenance is very important application, and intelligent maintenance system can reduce unexpected downtime and increase productivity. By this slide is clear, the picture?
Yes, sir, but clear, but actually it is very small. So
okay. So I will just skip the slide because it may not be possible to read it out. लेकिन जस्ट मैं दिखाना चाहे जूम करने से जूम होता है क्या?
यस सर, बिल्कुल जूम होता है.
अच्छा, तो मैं जस्ट दिखा रहा हूँ पिक्चर को कि आप लेफ्ट साइड में देखेंगे कनेक्टेड डिवाइसेस है, ठीक है? तो इसमें आप देखेंगे स्मार्ट ग्रिड्स है, एनर्जी मीटर्स है, स्मार्ट फैक्ट्री है, पंप्स है, गियर हॉबिंग है, इंजेक्शन मोल्डिंग है, प्रेस मशीन्स है. ये हमने डाटानेट से लिया है, इंटरनेट से ही इसको डाउनलोड किया है. तो ये आप देखिए कनेक्टेड डिवाइसेस है. So this is nothing but IoT. You can call it IoT or IIoT. Then it is going to PLC and DCS or SCADA. And there is a Datanis IoT agent. So it is through IoT platform. It is going to the big IoT data processing engine. Here, big IoT data processing engine collects all the data from these connected devices over a period of time. Let's say 3 months, 6 months, 4 months, or 1 year, you can say. And then finally, one analytic software is being run, and which is, see, the data from here is being taken to your mobile app or laptop or anywhere. Then finally, the analysis, the IoT engine and the analytical software, predictive software, produces predictive maintenance and predictive quality, then smart supply chain and smart energy management that our previous speaker has already said, as the case may be. So I will just skip this slide. Then how this artificial intelligence can be utilized in manufacturing industry. You see, there are so many hazardous locations in the steel industry where this artificial intelligence or robotics can be utilized. Now, this artificial intelligence, as our earlier speakers has already said, that there could be 3 kind of artificial intelligence. One is weak artificial intelligence, then strong artificial intelligence, and artificial super intelligence. We have not come to the artificial super intelligence stage, which many countries claim by this time, but we are already through with narrow and weak artificial intelligence and general or strong artificial intelligence. Now, weak artificial intelligence, you know already that Alexa is a virtual assistant artificial technology developed by Amazon. The Tony Reed is the name of woman who speaks for Alexa. Then we have seen the video games of chess, and then Apple's Siri is there, which is equivalent to Alexa. But if you talk about the general or strong artificial intelligence, the self-driving car is the biggest example of strong artificial intelligence. As far steel is concerned, these can be built up with the machines that thinks like human and sometimes like superhuman. It's a strong artificial super intelligence. So artificial intelligence can be utilized in steel or manufacturing industry, but right now the application is very limited as far artificial intelligence is concerned in manufacturing industry, because you need to have a lot many data, big data, and then analytical software. Now, unfortunately, analytic and predictive software, even if you take everything to the cloud, there are only few people, few technology supplier which are going ahead with this artificial intelligence application in metal and mining industry, manufacturing industry, so to say. Industrial robot is of course being used in metal and mining industry, but then its application is again very limited. Industrial robot can be very widely used in a hazardous area, or in the area where repetitive kind of things are being done, where human interferences are only limited. Our industrial robot are being used in steel industry. In Bhilai steel plant, we have put up one application wherein tendis manipulation for tendis manipulation. We have installed our industrial robot where the temperature is something like 600 to 700 degrees Celsius. So industrial robot works very aptly on there. Then machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. Machine learning, again, manufacturing industry, the uses are still limited, but it is developing very fast, and many cloud applications are in the process for development. Now, if we take all these, the IoT devices or PLC or DCS or servers to the cloud, then probably the cloud computing will come into the picture. Right now, we have taken the office automation infrastructure to cloud. Like we have got so many applications. The plant, the steel plant are very big, having 20 to 30,000 employees. Then we have got a very big setup of servers, and the terabyte of storage, where the payroll application, then maintenance management application, then the production planning application, then the process application, then the customer and supplier chain and everything. All these are being run on the servers, taking the data from all over the plant. And if we have so far taken these to cloud computing, but the process per se, we have not taken to the cloud because of the security problem. We have spoken about the cyber security, but in manufacturing industry, we are still wary of and afraid of cyber security. So if the process goes into the hand of some hacker, then probably he will control from there, and the entire chaos will be done. The last month only there were deaths of 4 people at Rourkela steel plant of gas leakage of coke oven gas, and you can imagine that if these are being controlled by hacker, then what will happen? Any mishap like Bhopal gas can occur in the steel plant. Now we are facing the challenge of the safety in the steel plants and manufacturing industry or chemical industry. Then I will skip this types of cloud computing. You already know that there are public cloud, private cloud, hybrid cloud. Then the cloud services, IaaS, PaaS, SaaS, Internet as a service, then process as a service, then software as a service. So I will skip this. I will also skip this cyber physical system and augmented reality, virtual reality. We have heard from our distinguished speakers earlier on these subjects. So I will skip this. Now, how to map various constituents of Industry 4.0 in iron and steel industry? That is a question. So far, we have come to know that Industry 4.0 can be applied in the manufacturing industry. But now I will switch over to iron industry, how it can be applied. Now you see there are 5 steps. And now which are these steps? These are shop floor automation, or the OT, that is operation technology, then manufacturing execution system, then enterprise resource and planning, and then followed by introducing digital technologies in back-end office. As I said that we have taken so many back-end office to the cloud, and to facilitate paperless and efficient and remote working, and finally shifting all such applications as far as practicable to the cloud. Now, how we have mapped Industry 4.0 in SAIL. So I will just try to explain before you the in short. Time is running out. Also, the status of digitalization in SAIL. See, there we call it level 0, level 1, level 2. Level 0 is nothing but agglomeration of all the process instruments. The conventional smart sensors are there, and instruments which we call it, which we place it at level 0. If these are being taken to PLC, programmable logic controller, and distributed control system, it is called level 1. And finally, we take it to the level 2, where online mathematical models in several processes like coke ovens for pause time control, blast furnaces, including stoves, converters, shops, casters, and mills. And finally, level 3 comes into picture, where manufacturing execution system takes place. And here also agglomeration of IT and OT also takes place. And then manufacturing execution system, and then enterprise resource planning, ERP. You will be glad to know that ERP we have implemented in SAIL, Steel Authority of India Limited, ERP system in all the integrated steel plant like Durgapur Steel Plant, Rourkela Steel Plant, Bokaro Steel Plant, Bhilai Steel Plant, and RNN Steel Company, Burnpur, ISCO Steel Plant. So this enterprise resource planning, how it works, I will come at a later stage. But the present level of automation in SAIL, as I said earlier, that level 0, level 1, and level 2. Now this sensorization as level 0, you see the sensors which can transmit data directly to the cloud through edge controllers for data integration, analytics, and reporting for real-time decision making. This is sensorization level 0. Presently, the sensors available in SAIL plants are not IoT enabled and hence cannot send data directly to the cloud. All the softs have conventional smart sensors. Conventional smart sensor I would like to deliberate upon here, which can give you the 4 to 20 milliamps. But suppose if you convert these sensors, if you have IP enabled sensors, which we call it smart sensors, unfortunately, the so many hundred and thousand of instrument supplier, they are in the process of developing these smart sensors, and they have done it for few sensors, but it is still very slow. मैं आपको इसलिए बता रहा हूँ कि इंडस्ट्री 4.0 के बारे में हम जो कुछ भी बोल रहे हैं, लेकिन अभी भी प्रोसेस इंडस्ट्री में अभी इंडस्ट्री 4.0 बहुत ही प्री मैच्योर्ड स्टेज में है, और it will take around 4 to 5 years to completely conceptualize industry 4.0. Our Dr. Jat has spoken about industry 5.0, but I fear, sir, that industry 4.0, if it will take 3 to 4 years or 5 years for complete materialization, then industry 5.0 is a distant dream. We cannot say dream because things are moving so fast, so it is possible. Now this since we don't have IoT enabled devices at steel industry, can it be seen as a bottleneck? So but then bottleneck is there, but there is a need to go ahead, and slowly we have to come to IoT enabled devices, and then we have to take all this data from different various of integrated steel plant is a very big plant, where we have in Bokaro itself, you'll be surprised to know that we have got 52 kilometers of fiber optic FOC cable laid inside Bokaro steel plant. Of course, that job I have done it as a consultant, in-house consultant of SAIL. We have done it. So you can imagine that the periphery of Bokaro steel plant is 23 kilometers lengthwise, but 52 kilometers of fiber optic cable has been laid inside the steel plant. So that way level 2 automation, level 1 automation is of course definitely very good, but as far industry 4.0 is concerned, I am skipping so many slides because we are running out of time. But one slide I would like to show you is manufacturing execution system. Before that, let me come to ERP devices. ERP, enterprise resource planning. ERP has been implemented in all the plants, as I told you, and we have the modules like, I'll just enlarge this slide. We have modules like FICO, finance and costing module, then PP, production and planning module, PM, production management module, QM, quality management module, SD, sales and distribution module, MM, materials management module. Now you'll be slightly wondering that why I'm showing this ERP implementation. ERP, if you accept it or not, this is a part of Industry 4.0. Many people, many steel plants still around the world doesn't have ERP, enterprise resource planning modules in place. So we in India slightly we are ahead of this. General has also ERP solutions. SR Mittal, already they had gone ahead with ERP solutions, and then many other steel players have already ERP solutions they have got. But we have implemented ERP in a big way in Bhilai steel plant, Rourkela steel plant, all the steel plants. So how does it work? It works with the production and planning module. You have got the forecasting of orders for next 2 years. Then it goes to from central marketing organization. It goes to a particular plant that you have to produce this. You have to have this kind of end products with you. Let's say with the customer name, of course, and the delivery period, of course. And then this production planning module passes on the data to production management module, and where the actual production management is being taken, and then quality aspect is being taken care by QM module. Then finally, in between there is a materials management module, because materials management is again important for a steel plant or for a manufacturing industry, because you have got supplier as well as your customer. So materials management work on both the end. Then it comes SD, sales and distribution module, where it is being passed on to the consumer or customer also, where now the efforts are on to enable the customers that in which stage your ordered the quantity or ordered item is in place. आप जान सकते हैं कि अगर मान लीजिए कि 3 महीने का समय आपने दिया है कि हमें इतना मिलियन टन का और इतना लेंथ का रेल चाहिए. सपोज इंडियन रेलवेज गिव्स एन ऑर्डर टू सेल व्हिच दे गिव नॉर्मली कि मुझे 160 मीटर का रेल चाहिए. कितना? तो कम से कम लेट्स से मिलियन टन के हिसाब से छोड़ दीजिए. For the sake of simplicity, I would say that 10,000 rail of 160 meter. Suppose I want to have, then Indian Railway can see that in which stage of their order their product is, and which is the likely date of delivery of the rail. So I will not take much of time here, because ERP, these are the modules which I explained here, and more or less I have spoken this for Bhilai steel plant, but more or less these ERP modules are present in all the steel plants, Now, question is, my question to our panelist, our distinguished speaker, Professor Jat, and our other distinguished speaker, Chaudhary Sahab or Nayak Sahab, that can we call this rename Industry 4.0 as complete digitalization of manufacturing industry? Can we do it? So we'll come to later on to this, that because complete digitalization, if we do in manufacturing industry, then Industry 4.0 can be conceptualized. So I will just skip these slides. We are running short of time. Then our earlier speaker, distinguished speaker, Jat Sahab, has talked about KPI, key performance index, or key performance indicator, we call it. So if you are aware of this steel process, then for implementation of the Industry 4.0, I am actually one of the member of implementation of Industry 4.0 in Steel Authority of India Limited. So we have identified KPIs for different shops. Now you may not be able to appreciate all this, because these are very, very metallurgy based. So steel melting shop, if I read out few of them, then the caster availability data, ladle availability data, segment health data, ladle tracking data, production data, number of heats, hours, shifts, day and day wise, and total metallic input. Then these you can have these you appreciate maintenance, breakdown analysis. Breakdown analysis. Suppose if you implement condition monitoring system on rotating equipment, like suppose you have got 200 kilowatt to 2000 kilowatt motor. If you implement condition monitoring system to know the vibration of the motor, to know the amperage of the motor, to know the bearing temperature, and if you could analyze these data as a big data, and if you could come to a conclusion that these motor are likely to fail, let's say after 3 months, the residual life is only 3 months. So what you will do, you will start planning after 2 months to replace this. Earlier, what was happening, that the motor will fail all of a sudden, and then you will have downtime, the process will be interrupted, and then you will have 2-3 days time, and 1 hour of time of blast furnace of Bokaro Steel plant is 1 hour of downtime is incurring 20 crore of rupees. You can imagine if we could implement this industry 4.0, we have got breakdown analysis of the equipment in steel plant, how much you will be in a position to save the money. So predictive analysis is very, very much important, and the root cause analysis also. So I'll just quickly summarize, quickly go through predictive analysis में इसमें आप देखिए ये आपके लिए थोड़ा सा इंटरेस्टिंग होगा कि रिफ्रैक्टरी लाइनिंग होता है। अगर ये हम जान लें कि रिफ्रैक्टरी लाइनिंग खत्म होने वाला है हमारा लैडल का, तो हमारे लिए बहुत इजी होगा, हम लोग नया लैडल प्लेस कर सकते हैं। लैडल का रिपेयर का शेड्यूल अगर पता चल जाए, टर्नडिश का लाइफ का अगर पता चल जाए कि एक टर्नडिश का लाइफ इतना बचा हुआ है, मोल्ड का लाइफ इतना है। हमारे यहाँ कास्टर में ब्रेक डाउन होता है, ब्रेकआउट होता है, जिसमें कि वो कास्टर का जो टर्नडिश होता है वो फट जाता है। अगर ब्रेक डाउन हम एनालाइज कर पाए तो हम करेक्टिव एक्शन ले सकते हैं। सेफ्टी में बहुत इंपॉर्टेंट है, जीरो एक्सीडेंट मतलब वी कैन अचीव जीरो एक्सीडेंट इज ए ड्रीम सो टू से, but zero accident can be achieved if we apply this industry 4.0 and IoT in safety. Then even environment, Indian government has become very stringent as far as environment is concerned. You have to have, after Bhopal gas tragedy and many other chemical industry and process industry tragedy and deaths every year of leakage of gas or the blast through and hot blast breakthrough, there are so many deaths. So there is a very strict adherence of environmental obligation on the part of manufacturing industry. So we maintain dust quantity, CO quantity, SOx, SO2, NOx emission data. So these can be very much applied, and we can achieve a good result to have eco-friendly. It cannot be truly eco-friendly still in the manufacturing industry, but at least it will be within the norms of government regulation. So I will finally say thank you to everyone. I have tried to give some insight that how Industry 4.0 can be implemented in manufacturing industry in general, and in steel and iron industry in particular. And I will summarize like this once again. I will leave it to the panelists here, that still Industry 4.0 is in a very, very premature stage as far process and manufacturing industry is concerned. It will take at least 3 to 4 or 5 years to completely conceptualize Internet of Things, industrial Internet of Things, the big data, and then if we take it to the cloud data, cloud computing, and virtual reality, augmented reality is of course a dream reality for process industry as far process industry is concerned. So I thank you very much, and the organizer and everyone for patiently listening to my this presentation. Thank you very much.
Thank you very much, Mukesh ji. Thank you very much for your excellent deliberation and citing the practical concept of the Industry 4.0 and how it is going to be implemented in your steel industry. But one thing what you have left for the panel, that whether the total core sector of the industry, particularly the process and manufacturing sector, can be completely converted to the industry 4.0 format or not, due to whether the digital transformation can be effectively implemented in every corner of the industry or not. So the thing is that my point is, and my observation is that we must have to have. Otherwise, because we have no just recently Dharam Singh ji has also cited what is the Prime Minister view on this respect. Because we will be implementing Industry 4.0, keeping the view that it should not replace the complete manpower, and that thing that completely it should be the effective management of the manpower, not the effective management of the robots. That has been very clearly told by the Prime Minister, in particularly in the Indian context. But in some context, you see, even if you don't want, but still then we should go for the complete digital transformation, because we have to survive in the competitive business market and competitive market, global market. Because the things that doesn't mean that for providing the, not retaining the manpower or not in the cost of the manpower, we cannot wait also. Because the thing is that why we cannot wait, because we should be also move in the same speed what speed the global industries are moving. That doesn't mean that when other country will move in the rocket speed, we may not go in the bullock cart speed. That is the main concept. But the basic concept is that wherever it is required, that will be a complete digital transformation definitely there. But the thing that how can we compensate, as I have told, because the utilization of these things, utilization of the different aspects and practical implementation of the Industry 4.0 definitely will enhance our productivity, effectivity, and profitability, and by which we can have the employment facilities into the rest of the manpower also. So we can having the power of setting more and more industries, more and more organization, where more and more employment facilities can be generated. Because I can give citing the example 30 years back when we have introduced the concept of digital transformation in banking industry. There was a complete resistance in the banking sector, and every week they are wearing the black badge and all these things. They are telling that all these things, and if the computerization will there, perhaps the people will lose the job. But that has never been happened, because we made the banking system to somehow smart banking system, and the people that rather we have in a position to recruit more and more people in the banks, and the surplus manpower have been diverted of setting up more and more new branches, because till today we are not capable to provide the per cap number of branches compared to our population. So that is the thing, because the efficiency productivity will be enhanced so that we can have more and more number of branches that can be happened. The same concept will be implemented here also. So that is why it is more or less we must have to welcome the Industry 4.0, and we should have a complete digital transformation in the industrial sector wherever it is possible. But definitely the thing is that we should try to minimize the use of the robots in every sector. But where it is required, where the cost of life is involved, there robotic concepts should also be welcome. And for example, the mining area, where the cost of life is involved, are the areas of the risk management you have told. In some of the cases where the cost of life is involved and some danger is there, also for preserving, there the robotation concept can also be welcome. There is no doubt. The thing is that we will have to see and we will have to decide how we can have a complete industrial 4.0 implementation, and viewing that is not compromising with our not compromising, but creating the environment of employing the surplus manpowers in other sectors, diverting the manpower to another sector, and engage them in some more industrial setup. That should be our motto. And I do think by this, definitely what you have pointed, that the risk management will be definitely optimized, the ecosystem definitely will be maintained, and a sustainable development and a sustainable sustainability, so far as the industrial efficiency and productivity and effectivity is concerned, the sustainability will be also preserved. That is the basic purpose of Industry 4.0, as I believe. And with us by the meantime, Professor Mahinder Singh is connected, right? or Himachal Pradesh Central University, Dean Rohit.
No, sir. Sir is not connected, sir.
No, not connected. No problem. So this is my observation. There might be, because Chaudhary sir is there, he here also. He might have some separate observation, another observation, and Dharam Singh ji be there. They can have some observation, but I have just pointed out what is my observation. So, and I always look forward for the positiveness. Okay, thank you.
So thank you so much, sir. And now
Any observation you ask to Chaudhary sir or Dharam
yes,
sir?
Yes. So as Nayak sir already told you, sir. So if you want to share, you can share, sir. NS Chaudhary, sir.
Yeah, good afternoon. I think we had, in fact, very informative and detailed discussions, and Professor Nayak has already said about a lot of things. Humanness is most important. And you see, the technologies that we are talking about, particularly the complete digitalization, yes, okay, the automation will help. AI taking to various levels has already been talked about. And in the, you see, the manufacturing, the way we have seen, okay, particularly this is industry 4.0 that we are talking about. And in that context, I would say that yes, AI, okay, will have various applications, various percolations, but complete digitization, you see, there will always remain a human element. That is my personal opinion. And that is where our, as far as the technological education is concerned, I already mentioned that great emphasis is now being put on the human values. And the need for the human values and the importance of human being in the technologies, in particularly development of the technologies. You see, the intelligence drives the technology. Technology improves. With the improved technologies, okay, we can take our intelligence to the next level, because we are able to do lots of other important aspects, other important things. You see, there is a vicious circle that technology improves. With the improved technology, we are able to now think about the intelligence at the next level. With the intelligence at the next level, again the technology improves, and so on and so forth. But the human element will never be lost. I think that is my comment. And with that, we already are restructuring our syllabi. We have already done that to a large extent. And well, I would like to, in fact, end with a note saying that, okay, this is a very important aspect, and in future, okay, human beings will never be replaced, and that is what we hope so. Thank you. Jai Bharat.
Thank you so much, sir.
Thank you, sir.
Thank you, sir. And now it's a time to
मुझे धर्म जी का if any comment is there.
Yeah. Sure, sir. Yeah, Dharam Singh, sir.
Thank you, Prof. Thank you, Prof. Chaudhary, Prof. Nayak, Prof. Rohit. Just during my presentations, I already gave some studies, CEO studies, near about 200 CEO studies about the impact and implementation of the new technology, artificial intelligence in the industry. First thing is, now we are going to industrial revolution 5th now from this century. And now we are still talking for industrial revolution 4 that we have to implement or we have to not implement. So I think the major hurdle is about the manpower. So you see, the manpower is not a problem. Some of the studies said that they need to develop a skill with the existing manpower. They need to upgrade, and they need to find out the way, like the training or other type of courses. But right now, you see, the time is the technology time. So every person's need to upgrade every day. Either it's a technology part or either it's other parts. So we cannot remain with the traditional things. Even though in home We cannot stay with the traditional things. So we have to move with the new technology. Industry need to move technology. I think there is regarding to job creation, the job there will be no effect, may not be effect, maybe effect from the category A, and we may create a job in the category of B sides. So I think it's job is not a problem. And as technology is evolved, then there is a more chance of job creations in the world. So that is my the comments. Thank you.
Thank you so much, sir. So same thing I want to ask with Dr. R.R. Desmukh, sir.
So, good afternoon, everybody. So, Rohit, I think I have to conclude, no?
Yes, sir.
Overall. Yeah. So, I will share my opinion within my concluding remark as per the opportunity shouldered me by respected Professor Naik, sir. So, Honorable Dias, chief guest of this webinar, Dr. Narendra Chaudhari, sir, Vice Chancellor, Uttarakhand University, Dehradun. Keynote speaker, Professor Dharam Singh Jat, sir. Mr. Mukesh Naik from industry, that is Steel Authority of India Limited, Ranchi. My mentor, Professor Naik, sir, Rohit Kumar, and Mr. Pandeji, Professor Pandeji. So first of all, I would like to thank my mentor and immediate past president of CSF, Computer Society of India, Professor Naik, sir, to give me this opportunity on the on the time to share or to conclude this session. I am very much connected with Professor Narendra Chaudhari, sir, since last more than 10 years, as well as keynote speaker Professor Jat, sir, during last 4 or 5 years in the means of Indian Science Congress. He was the one of the foreign speaker in Indian Science Congress conducted at Jalandhar. He accepted our invitation and he was there, as well as the industry person, Mr. Mukesh Kumar, sir. So, in the concluding remarks, I would like to share that both these speakers, that is Chaudhary, Professor Narendra Chaudhary and Professor Jat, sir, has discussed and explored much more, so many things regarding the Industry Revolution 4.0, starting from 1.0, 2.0, 3.0, in the by different giving different examples as a academia and Industry 4.0, which is the part of new education policy. So in the recent new education policy declared by Government of India or Department of Education, Government of India, that India is moving towards becoming a true knowledge society and sustainable energy society, along with adopting or accepting the Industry 4.0 revolution, in which increased employability opportunities will be provided or made available, along with more skilled job of creative and multidisciplinary natures will be made available, and this education system will be ready to cater increased GER with proper support of the industry. So considering all these points, as I am also working as one of the member to design and development of a curriculum of newly announced 2-year MCA course by AICT of India. I am one of the member of All India Board of Technical Education, IT Board of IT, under the leadership and mentorship of Professor A.K. Naik Saab at AICT New Delhi. We are in the process of devising a curriculum to all for the institutes running all over the India. And this Industry 4.0 is a part of that. And I think organizers has selected or choose very good topic or hot topic which needs to be discussed in current scenario, where the academics and there is academicians or leading academicians from India abroad are involved, along with the industry persons also. And I think there was a very good discussion, as Mr. Rohit Kumar has shared his view in the context of industry. What is the situation or what will be the scenario of this Industry 4.0 in industry also, isn't it? So as per my opinion, that as shared by Professor Chaudhary sir and Nayak, that is Professor Jat sir, Germany has adopted all these concepts or started adopting all these concepts since that is Industry 4.0 from 2013 to 14. We are going to adopt, or we are adopting during a couple of last, that is 1 to 2 years, we have started to have a Industry 4.0 concept. And in 2021, we are entering in the in Industry 5.0 revolution. So definitely the question raised by this Professor Rohit Kumar sir, whether there is a possibility of complete digitization of the industry.
Mukesh Kumar ji, Mukesh Kumar.
Mukesh Kumar. So on this point, Professor Nayak as well as Chaudhary sir and Professor Jat sir has very well said or shared their views, and Nayak sir has explored all the aspects regarding the complete digitization of the industry. So that is, man cannot be replaced by anybody or anything. So there will be no possibility of 100% of that is, but we can have optimized use of digitization. Means wherever possible and wherever there is feasible. That is where if there is a risk factor, then we can have a digitization, or we can motivate the digitization part or automation part there. But man cannot be replaced in all the sense. This is there is summary of overall discussions from all the dignitaries, our panelists, those who have shared their views. So I think with this, that is, we are already out of time, and I will not go for more. Again, I would like to thank all the speakers and organizers to give me this opportunity to interact with. And Professor Jat Sahab, namaste.
Sir, namaskar. And I would like to share that Prof. Deshmukh is also the member of advisory board of our master and PhD program.
Yeah, at Namibia University. Yeah. Yes. So thank you. That is, I hand over the control over the that is Rohit Kumar.
Thank you so much, R.R. Deshmukh sir. And with these, we are now towards our last session, that is vote of thanks. And for that, I'd like to welcome Professor Ganesh Pandey sir, who is the Deputy Director of Indian Institute of Business Management, Patna.
Thank you, Rohit. Honorable Chairman of the National Webinar, my Guru, my mentor, Professor Dr. A.K. Nayak, Advisor, IIBM and GTI Group of Institution, former President and Fellow CSI, and former President ICT Section, Indian Science Congress. Honorable Chief Guest, Dr. Narendra S Chaudhari, Vice Chancellor, Uttarakhand Technical University, Dehradun. Honorable Keynote Speaker, Dr. Dharam Singh Jat, Professor, Department of Computer Science and Engineering, Namibia University of Science and Technology, Namibia. Honorable invited speaker, Mr. Mukesh Kumar, General Manager, Steel Authority of India, Ranchi, Jharkhand, and participant of the webinar. It is my privilege to express my sincere gratitude and present my vote of thanks for the Honorable Chairman of the function, my Guru, my mentor, Professor Dr. A.K. Nayak, who has been instrumental for conducting near about 550 number of webinar under the banner of CSI at different locations of the country. On behalf of the IIBM Management Committee and a student community, we express our sincere gratitude and thanks for delivering the inaugural address on this occasion. We are all inspired by your great words, sir. I am also equally thankful to Chief Guest Dr. Narendra S Chaudhari, Vice Chancellor, Uttarakhand Technical University, who has spent his busiest time gracing the occasion. Today, we had the opportunity to hear your thoughts, and this is definitely encouraging us in our future events. My expression of vote of thanks from the core of my heart to the keynote speaker, Dr. Dharam Singh Jat, Professor, Department of Computer Science and Engineering, Nambia University of Science and Technology, Nambia, for his keynote address. My special thanks goes to Mr. Mukesh Kumar, General Manager, Steel Authority of India, Ranchi, for their gracious presence and addressing with their valuable words in this webinar. I would like to express our sincere thanks to Dr. R. Deshmukh sir for giving excellent coverage. Thank you very much for joining this event. I also express my sincere thanks to Professor Rohit Kumar for hosting the event. Last but not least, my sincere thanks goes to all participants of the webinar who made the event successful. Thank you, sir.
Thank you so much, sir.
Thank you, everybody.
So with all these words, I like to sign off our today's webinar, and I pray God that this webinar will have a great success. And with these words, I like to take permissions from all the dignitaries, and signing off this meeting.
Thank you very
so much,
much.
all of you. Thank you so much.
Thank you, Dharamji. Once again.